Okay, hi guys. This is Gopala Krishna Korapati. Can you guys hear me fine? Uh,
Sir, good morning. Can you hear me? Probably on live.
Hello. Yeah.
Hello, sir. This is Anisha here. Good morning.
Yeah. Good morning, Anisha. Can you guys hear me good?
Yeah, we are able to hear you good. And just give us 2 minutes. We have 2 to 3 joining in. So we'll start it.
Okay. Okay. Sure.
So good morning, everybody. Today we have a session about blockchain. So it's going to be an introductory part of what blockchain basically is. Probably yesterday you had an idea. I mean, yesterday you had Vikram sir who spoke about blockchain and how is it used in research. But today's session would be wherein you would be knowing how does basically blockchain works and what exactly it is all about. So today we have with us Gopala Krishna sir, who is currently working as a senior software engineer at EV Core Healthcare at United States. So over to you. Please, you can take up the session hereafter.
Okay. Thank you, Anisha.
Thank you.
Hi guys. Good morning. So basically today I'm going to give some brief introduction of what blockchain technology and how it is basically working and some of the IBM experts. I am going to play some of the IBM experts videos describing what blockchain and how IBM is working towards blockchain and what solutions they were providing to the other clients using the IBM technology for blockchain. So basically, today we will be listening or taking up into the three videos, and most of them are going to be like this. So, so what is a blockchain? And example blockchain networks and IBM and blockchain, how they are working on it. Basically, blockchain itself, the name itself indicates it's a chain of blocks. So what it does is for each record, it is going to create an individual block. And how are the records going to interact between all the blocks is going to be in this manner. I don't know if you guys remember your data structures where linked list, single linked list, the blockchain backend literally uses the same technology, same concept of single linked list. So basically it has the previous hash map, the existing hash map of that block, and the data. Whereas how these blocks are getting connected are using the hash map concept of each individual block. The thing is, it consists of previous hash map, and that's how using the hash map, the contents, the chain is going to be interacted between all the blocks. So, so what is blockchain? And here in this example, blockchain can be used in different industries like finance or food chain or anywhere where they want to share the same set of information across different individual part of departments or the individual each company having different clients. So when they want to maintain a single set of record for each of those clients, nowadays some of the companies are moving to this blockchain instead of maintaining the manual records. uh, the blockchain is helping them to maintain the contracts, ledgers, transactions and everything are going to be interacted here. So coming to this one, for this initial one, what is a blockchain and business networks, and how blockchain solves this problem, or different types of blockchains, requirements of blockchain for business. So for that one, we'll take a look at this video right now. And I hope you guys can let me know if you guys can hear the video audio or not.
My name is Matt Lucas from IBM, and in this first module, part of the IBM Blockchain Essentials course, we will discuss what blockchain is. We'll start by looking at the business context in which blockchain applies. Businesses never operate in isolation. They participate in business networks. Business networks connect customers, suppliers, banks, and regulators, and will often cross geographical boundaries and different industries. Wealth is generated as goods and services move across these business networks. Car manufacturers will pay suppliers for raw materials to assemble a car, which is then sold to dealers who then sell the car to us. Markets facilitate this process of exchange. There are public markets that anyone can join and private markets that are restricted in terms of their membership. However they work, efficient markets help.
So in this screen here, in this one, business networks, how they are going to be participants, suppliers, banks, or partners. You can treat each individual one of them as their clients, and how the flow of data is going to be transferred using the blockchains, and what does the wealth actually represents, and market, whether it is a public or private or different types of markets they were talking about. Let's continue.
Wealth to be accumulated by their participants. Conversely, growth of wealth can be constrained if the network is heavily siloed or inefficient. The term asset is used to describe anything of significant value. Assets typically change ownership as they flow between participants in a business network, usually in exchange for payments. We tend to think of assets as tangible, things that we can see and touch, like cars and houses. But assets can also be intangible. For example, financial instruments, intellectual property, customer data, or the right to listen to a piece of music. Money is, of course, an asset too. Cash, physical notes and coins, is anonymous. There's no way for people to prove that cash is theirs, other than the fact it happens to be in their wallet. This makes it difficult to track and difficult to tax. This property is important when we look at different blockchain implementations later on. Ledgers are arguably the most important systems of record in any business. Ledgers are simply transaction logs, and are important because they can be used to show what assets a business has, and therefore what a business is worth, which in turn influences investment decisions. A ledger comprises transactions, which shows the changes in ownership of assets as they flow into and out of a business. More generally, transactions can be used to describe any change in state of an asset. For example, if respraying my car from yellow to green increases its resale value, this might be useful to log. Transactions are underpinned by contracts, which describe the business rules or prerequisites for a transaction to be valid. If I sell my car to Dave, the terms of that transaction, for example, the circumstances in which Dave can get his money back, are agreed by both of us before we transact. There are problems with both ledgers and contracts, which stem from the fact that there are multiple participants who have a vested interest in their contents. How do I know that the transaction I've recorded in my ledger tallies with the transaction that Dave's recorded in his? How do I know that the contract, the business rules associated with the transaction, are interpreted and implemented consistently between us? The answer to both of these questions is we don't, and this can lead to significant costs of reconciliation, dispute resolution, and legal processes. Blockchain aims to solve the problems of ledgers and contracts by allowing transactions and business rules to be shared between the participants of the business network. Blockchain can be thought of as a shared, replicated ledger with smart contracts. So blockchain is a ledger, a transaction log, but it is shared between participants of the business network so that the transactions each participant sees is identical. It's also replicated. Participants retain copies so as to avoid any single points of failure. Smart contracts provide the shared implementation of the business rules associated with each transaction. Smart contracts are just pieces of computer code. As of today, they are not contracts in the legal sense, but they exist in the same way that IT systems execute the terms of a contract today. This sharing of transactions and contracts is the foundation for innovative business solutions, including the ability to remove ambiguity and friction from trade. Here is an example business network that contains 6 participants. Notice that before blockchain, each participant has their own ledger, represented here by the books in different colors. Transactions between the participants are done point to point using a variety of mechanisms depending on the preferences of the participants. Maybe over the internet, using file transfer, messaging systems, or older mechanisms such as phone calls or postal mail. Such a business network is expensive due to reconciliation, duplication of effort, and intermediaries adding margin for services. It is clearly inefficient as the interactions are managed point to point and the business rules are implemented by every network participant. It is also vulnerable because if a central system is compromised, maybe through fraud, cyber attack, or a simple mistake, this can affect the whole business network. Now we have added a blockchain to this business network. It means that authorized participants can invoke transactions with each other and share smart contracts that underpin them, assuming agreed levels of privacy and confidentiality, of course. The blockchain gives the business network 4 qualities of service: consensus, provenance, immutability, and finality. Consensus means that participants will collectively agree that each transaction is valid and the order of the transaction in relation to others. Provenance means that participants know the history of the asset, for example, how its ownership has changed over time. Immutability means no participant can tamper with the transaction once it's agreed. Finality means that once a transaction is committed, it cannot be reversed. In other words, the data cannot be rolled back to the previous state. If a transaction was in error, then a new transaction must be used to reverse the error, with both transactions visible. Note that while the participants are exactly the same as before, because transactions are now more transparent, inefficiencies in the business network, such as participants who do not add intrinsic value, may well become optimized out through market forces. Blockchains are all about...
Okay, I don't know how far you guys concentrated here. So I'm going to explain this screen here. So before the blockchain, as mentioned, ledger is nothing but a book or record that stores every entry of an company. So it used to be, if a company has this kind of network, every individual participant has to have their own ledger. And there were sometimes used to have some of the errors during the contracts that each participants or that are going to share between the ledgers. And again, there will be a lot of duplicate efforts that being trying to do by each individual block here. So to avoid that, this blockchain technology is going to solve that problem here of maintaining the block, which is common. So literally each one has its own block here, but that doesn't mean that each one is maintaining a separate block there. They can have that block and it is going to be shared across using the securities inside the blockchain technology. They can share with that each individual block has to be shared with only certain participants or across all the participants. So let's say that if you see that the transactions between participant A and B is going to happen all the time, but for these transactions has to be logged into the bank records, auditor records, regulatory records, and insurance records all the time, irrespective of whether it is a small or a large. So instead of sending multiple, they are going to share this block with their bank records or with all the corresponding records simultaneously. And the data here is going to be a key role. And in this blockchain, if there is any error that happened with that transaction or data, they cannot simply update the data directly, because if you do that, it is going to break, because each time a manipulation happens to the blockchain, there will be a new hash code that is going to be generated for that. So in order, if a set of data has been generated inside the blockchain, you guys, if there is any error, it has to be corrected, and reevaluation of all the transactions that has happened across those blockchain has to happen there.
Authorized
We'll continue.
Participants can invoke transactions with each other in the business network, such as participants who had cryptographic proof, but different blockchain implementations require different other characteristics. For example, many people's first experience of blockchain is through Bitcoin. This is a peer-to-peer payment system that allows people to send currency to one another without requiring a centralized intermediary, using a class of asset called a cryptocurrency. Bitcoin uses a blockchain to log all transactions and a resource-intensive process called proof of work to achieve consensus. Transactions in Bitcoin are public and visible to all, but the participants behind each transaction are largely anonymous, which makes it very difficult to track. The requirements of blockchains for business are generally different to Bitcoin's. Firstly, blockchains for business are used to track any assets of value, tangible or intangible, and are not restricted to cryptocurrencies. Secondly, regulated businesses have requirements such as KYC, know your customer, and AML, anti-money laundering, which require them to know who they are dealing with. Participants on business blockchains have known identity using digital certificates, which also allows transactions to be signed and encrypted. Transactions on business blockchains can be viewed by only those with a need to know, for example, a regulator. In public blockchains, the ledger is visible to all. Thirdly, in order to keep transactions confidential, businesses need fine-grained control over who agrees to or endorses transactions. In business blockchains, transactions are endorsed by a small subset of participants, such as those affected by the transaction, and maybe a third party, such as a payments provider. This is much more energy efficient than proof-of-work-based blockchains, such as Bitcoin, which not only require a majority of the network to endorse a transaction, they also require transaction validators to arbitrarily burn electricity in order to remove incentives for fraud. In this module, we have discussed the business context behind blockchain, the fact that businesses operate as part of a network which flows assets in order to generate wealth through transactions that are underpinned by contracts and logged on a ledger. We discussed the problems of ledgers and contracts, which stem from them representing different interpretations of agreements between participants and are therefore prone to disputes. Blockchain solves these problems by sharing and replicating the ledger, and also introduces the concept of smart contracts, which provide the shared business rules behind a transaction. There are different types of blockchain. Blockchains for business generally prioritize privacy and confidentiality, and are much more resource efficient than their public counterparts. Thank you for watching this module, which is the first in this IBM Blockchain Essentials series. In the next module, we will look at some blockchain solutions that businesses have implemented.
So coming to the next module, they are going to discuss about overview of active networks, TradeLens, IBM Food Trust supply chain transparency, global payments, decentralization and trusted identity, further examples by industry, key players for blockchain adoption.
Hello, I'm Dave Gorman from the IBM Blockchain Engagement team. In this second module from the IBM Blockchain Essentials course, we will be reviewing and discussing some of the real networks that IBM has been building over the last few years. At IBM, we've been helping our customers to build blockchain-based solutions for the past few years now, and we have many active networks processing live transactions. This slide shows just some of the industry areas in which we have been actively building these networks. As you would expect, there are a number of financial solutions we have been building. For example, WeTrade, that can be seen in the bottom left of the slide, is a consortium of banks based in Europe. The WeTrade platform provides trade finance to small and medium customers who would otherwise have found it difficult to gain access to trade finance. It allows banks' customers to connect with other banks' customers on the network, to agree their contract terms, gain access to financial products, and then to track the goods as they are sent from the seller to the buyer. Another example is our work with Tenant in the bottom right of the slide, where blockchain is being used to underpin a platform to help balance the electricity grid in Germany by storing and releasing electricity to and from batteries that are stored in people's homes. On the next slides, we'll see further examples mentioned here that cover global trade, universal payments, food, and identity. This slide introduces TradeLens, which is a live platform for global trade. Originally developed by both Maersk and IBM, it is an open platform that has been built to serve the entire industry. 80% of the goods used by you and I daily are carried by the global shipping industry, which has a high degree of manual and paper-based processes. The platform is designed to be inclusive of all participants in the global trade ecosystem. As the diagram on the right of the slide shows, every organization from the shipping companies to port authorities, customs and supply chains are included. The platform enables data for the shipping containers to be captured and shared between the appropriate participants on the network. By increasing transparency of the events and data for a shipping container, other processes can be made more efficient, such as cross-border transactions. A large amount of cost and time can also be eliminated by the digitizing of documents related to the shipping containers and making these proofs available to other participants. CMA, CGM, and the Mediterranean Shipping Company, MSC, have announced they will also join the network, who with Maersk and the other network participants means that data from nearly half of the world's ocean container companies will be available on this platform. This slide introduces the IBM Food Trust platform, which is a live system for tracking the provenance of food through the complex network of supply chains. The platform is built to include all participants across the food industry, from the farmer to the end consumer, an example of which can be seen in the diagram on the right of the slide. With only 1 in 4 consumers trusting the food ecosystem, it's not difficult to see why a platform that enables food to be traced more easily might be beneficial. The platform captures information related to food products as they pass through the supply chain. This includes things like raw ingredients that are subsequently used to produce other food items. For example, the raw ingredients for making a pizza can be traced from the farms where the wheat is grown and the cheese is made, through the distribution chains to where they are used to make the pizza, and then traced to where the pizzas are sold in supermarkets. The platform comprises a number of different modules, which are trace, certifications, fresh insights, and third-party modules. The trace module enables the location and status of goods to be tracked both up and downstream in the supply chain. This enables, for example, the location of contamination to be identified quickly and helps to prevent fraud. The certifications module allows all the messy paperwork to be captured digitally. This might include, for example, inspection documents and quality certifications. The benefit of this is improved processes within the whole ecosystem, as information is captured once in a secure and trusted way and can easily be checked for proof by other organizations. The Fresh Insights module is all about real-time analytics of what is happening in the supply chain. How much time has food spent in a warehouse, for example, could significantly change its shelf life, and so having real-time insight to the inventory flow can help make supply chains more efficient and reduce waste. Lastly, there are the third-party modules. The platform has been designed to allow partners to build and supply modules that provide additional value to the participants on the platform. This slide introduces IBM WorldWire, which is a...
So, as mentioned, let's take a brief of what Food Trust, how it is, blockchain is helping there. So for each block, they have to make an entry into this, and it is going to be shared across all of them simultaneously. What happened for each individual transaction when the actual form is going to send it to the processor department and processor to the distributor, distributor to the retailer, and final food is made and distributed to the customers. So the main problem they are solving here is the transparency of how, when and how long the food has been processed, and how long it's been with each individual department here, and a single set of record across all the departments is going to be maintained. So it is giving appropriate data, and no one can alter the data once it's been published into the blockchain. And tampering of the data is not that easy. And the actual data for the end user is also going to be there for that particular food, when it was actually formed, and how long they took to process it inside the processor, and how long it was on the distributor warehouse, and all those things. Now, the next example, they are going to discuss about blockchain in financial.
Participants on the platform, border payments. It allows banks and other financial institutions to send and receive payments across different currencies that can be settled and cleared in near real time. Traditional cross-border payment systems involve many intermediaries, and typically there is a lack of transparency on the state of the payment. This can lead to errors which require costly and time-consuming reconciliation to fix. These traditional systems also have high transaction fees, with each of the intermediaries charging a fee to process the payment. Finally, these systems also have a high degree of latency, meaning settlement times can often be measured in days. IBM WorldWire simplifies this traditional approach to cross-border payments by streamlining the process and therefore reducing the need for many intermediaries. Fewer intermediaries means lower overall transaction fees. There's also transparency of the payment in transit, which reduces unnecessary issues and means that if there is a need to reconcile any issues, that it can be done more quickly. The platform can also settle and clear the payment between the sender and the receiver in near real time. It's built using the Stellar blockchain network, which is a public network, but importantly has permissioning as well. A number of digital assets are supported to handle the clearing and settlement between the different banks and financial institutions. It's really this digital asset that is the novelty and can include cryptocurrencies such as Lumens, which is the native Stellar currency, or a digital obligation, which is a promise to settle in the future, stablecoins, which are digital tokens linked to a fiat currency, such as the US dollar, and digital tokens issued by central banks. The last of these slides represents an...
So in this screen here, you can clearly see the right-hand side is with the blockchain and the left-hand side is without the blockchain. So if a customer has to send an international or any transfer, so what happens is normally they have a middle third-party company, third-party banks or third-party companies, where they take the transaction and they convert it and then they deposit into the end banks. So during this time, what happens is they have to verify whether the network is completely trusted and whether all the contracts has been made for that particular individual transaction is there, and whether there are any things that are going to be there and all those things. Due to all this process, what happens is it is going to be a delay in the process. Delay in the sense it takes time to the actual transaction has to happen. And due to these middle layers, there will be some extra cost that each individual has to pay as an fees. So whereas coming to the blockchain, if these third parties are already, I mean, we can avoid some of the third parties inside the blockchain. And if the sender and the receiver banks are already within that blockchain, that means they have mutually agreed and their contracts were clear and everything was built ahead of time with using the blockchain there. And due to this, they can literally see that according to IBM, their technology here, they can make it the transactions say up to 10 to 20%, and overall transaction costs are going to be here reduced from 55 to 85. That's what they were mentioning. But here the concept which we need to look is, due to this blockchain inside the financial, international transfers are happening fast and with less fees rather than paying little expensive fees with the existing environments there. Let's take the look at the next example.
Issued by central banks. The last of these slides represents an area of growing interest with the use of a blockchain to underpin a network for trusted identity. The problem we have today is that we each have many forms of identity, such as passports, driving licenses, educational certificates, etc. Each time we're asked to prove who we are, for example, when taking out a mortgage to buy a new house, we have to show these forms of identity as proof. This often results in more of our personally identifiable information, or PII, being given which isn't really needed. For example, showing someone my driver's license to prove my age not only shows my age, but my name and address, etc. The other issue today is our personally identifiable information is stored in numerous places by different institutions which act as honeypots for thieves and hackers who are out to steal our information. A trusted identity blockchain puts the holder, that's you and I, in control of the credentials that represent our identity. This is also known as self-sovereign identity. The content of the credential, or PII, is never stored on the blockchain. Only the public certificates are stored on the blockchain, which are needed by an organization wanting to verify a credential. Organizations such as the government might issue credentials to the holder, and an organization such as a bank might verify the credential. One such example of a blockchain network for self-sovereign identity is Sovereign, as seen on this slide. IBM is one of the stewards on the network, which means IBM runs a node that helps to maintain the sovereign distributed ledger. On this slide, we can see many further potential examples across different industries. It's fair to say that the financial industry was the first to really start experimenting with blockchain, and we saw a lot of interest from this sector initially. As our experience with the technology grew, so did our understanding of how blockchain could be used to underpin solutions for problems in any industry. The final slide in this module shows some of the key players, as we call them, when it comes to the adoption of blockchain. Regulators are very interested in blockchain, especially when they can be a part of the network. Blockchain gives a regulator the chance to have a real-time view of what is happening within a particular part of their sector. A number of industry groups have formed that allow organizations to form opinions and best practice on how they might use blockchain technology. For example, MOBI, or the Mobility Open Blockchain Initiative, is looking at blockchain and other related technologies to see how they can make mobility more efficient, greener, and safer. And lastly, our market makers, who are providing new and innovative products, features, and processes to the rest of the industry. In this module, we saw there are many active blockchain networks today across different industries. Examples we discussed were TradeLens, IBM Food Trust, the IBM WorldWire platform, and the concept of trusted identity being provided by the Sovereign network. And finally, we looked at who some of the key players are in enabling blockchains.
Okay, I will stop here for the module 2. And so I just want to give, so public sector, I mean, these are the different sectors. I'm sure some of you may not be aware of what actually these are. Financial is nothing but our bank transactions. Public sector is nothing but our government sector related documents. Retail is nothing but supply chain. It's nothing but we can take it as an example of Amazon as the retail there. And insurance as a regular our insurance, any SBI, ICICI, any insurance companies. And manufacturing is their actual provider of actual manufacturing of the goods. Those fall under manufacturing. So all these sectors, there is the possibility that using the blockchain will reduce a lot of ledger accounts or transactions to be open and to be secure and to be accessed by only certain set of departments that were given access. So all these different companies in over the world which falls under these sectors are currently thinking at least of thinking of migrating to the blockchain, depending on each individual company there and organization there. But most of them already started. So I just want to give a glimpse about this sectors here. So the last one is how IBM is helping the blockchain projects and what are the different strategies they are following, and Hyperledger project of Linux Foundations is going to be there.
Hello, I'm Matthew Golby-Kirk from IBM's Blockchain Engagement team. In this third module in the IBM Blockchain Essentials course, I'll show you what IBM is doing with blockchain and how it's helping clients make blockchain real for business. There are many things to consider when starting to build a blockchain solution, and 3 key ones are listed on this chart. 1, how can I secure the solution that I'm building? 2, who can I trust to help me implement the solution? And 3, how can I bring together my business network and get them to join my solution? IBM can help you with each of these challenges by providing the certainty that we can solve these problems together. Let's look at each one of these in turn. First, security at scale. We can provide you with the most secure blockchain infrastructure with the highest security rating in the world, all managed on IBM Cloud. You can control the participants, roles, and access, giving you peace of mind about who can see your intellectual property on your blockchain network. IBM has a proven track record of using blockchain to transform regulated industries, solving problems like identity verification and bringing trust to financial transactions. The IBM blockchain platform meets the performance and trust requirements of even the most highly regulated industries. We run over 55% of the world's transactional systems, helping to ensure your transactions and network never go down. Next is trusted expertise. We have the deepest pool of blockchain experts in the industry, building and running business-ready networks today in production. We can provide unparalleled experience with tools that ease collaboration and allow you to activate your blockchain networks faster. We can help you go further, building on what you have today to stand up production-ready blockchains. We build, run, and manage active networks for businesses at scale across retail, financial, services, logistics, and government networks. As one of the lead contributors to Hyperledger Fabric, we have designed flexibility into the technology to adapt to business needs as those needs evolve over time. Lastly, we can bring analytics to your blockchain, enabling you to learn more from your blockchain data through artificial intelligence. Finally, there is network convening power, which is how can you influence your participants to join your network. We know that blockchain enables new business models, but only IBM has the ability to bring together industry-leading partners, organizations, regulators, and suppliers to create blockchain networks in this collaborative environment. We have had hundreds of client engagements to date and delivered some of the earliest and most successful blockchain collaborations. America's largest retailer puts their trust in our network to track food safety across their vendors around the world. With more active blockchain networks successfully running today, we can help you create the right blockchain solution. This chart shows a high-level overview of IBM's strategy for blockchain. The foundation of everything is IBM's continued participation in the Hyperledger project, which sits at the heart of the IBM blockchain platform. And it is this platform that allows business networks to form and expand blockchains together in democratic ways. The solutions on top are the ones that IBM has developed and continues to develop to solve particular industry needs, such as supply chain with Food Trust, global shipping with TradeLens, and cross-border payments with WorldWire. At the top of this chart, you can see that in order to help with forming and scaling networks, we have nurtured an effective ecosystem of business partners. Lastly, and critically to all of these aspects, as you can see down the left-hand side, we have a services capability that can help make your blockchain network a success. This slide zooms into the platform to show it in more detail and illustrates the platform on a single chart. IBM Blockchain Platform is not just a hosting platform, but it aims to help with the entire lifecycle of a blockchain solution, right from inception through to deployment and beyond. The simplified architecture diagram on the right shows how the platform is put together. It has flexible deployment options, allowing you to deploy anywhere from IBM's cloud or on-premise.
So this is more towards what services they were offering. So the only thing is, what we need to understand is how the ecosystems and what are the problems that the current industries are facing, and how we can accomplish them using blockchain is the main motive of using the blockchain in any industry here. That's what we need to do. I mean, we need to understand more regarding that if we are going to look into any of these aspects. The only thing is any blockchain, they are providing these features altogether. I mean, I thought it is more useful, simpler way to go with these IBM examples here. Security, trusted expertise, and network convenience power. That means these are the main aspects of a blockchains that are going through different blockchain tools or companies that are providing there. So most we can conclude this what a Hyperledger and a Linux Foundation project, how these guys worked, and we'll take a look at that one, and we can conclude this here.
It is important to correctly distinguish between the terms and projects here. Hyperledger is a trademark of the Linux Foundation and is the umbrella for a group of technologies designed to advance blockchain for business, as we can see in the greenhouse diagram to the right. Hyperledger Fabric is one blockchain platform that sits underneath this umbrella. There are many contributors to Fabric, including IBM. Other frameworks include Iroha and Sawtooth. IBM Blockchain is used to describe the breadth of these technologies and services that are uniquely supplied by IBM, for example, the hosting on IBM Cloud. One of the key differentiators for Hyperledger is open governance. This means that there is no one controlling organization that governs the direction of the project and no lock-in to one particular vendor. Open governance is the key to all of the Linux Foundation projects. As we saw earlier, Hyperledger Fabric is at the heart of the IBM blockchain platform and is one of the Hyperledger projects that IBM is significantly investing in. Although it is important to note that Fabric is not an IBM project, it is actually open source, as we heard earlier. Version 1 was released in July 2017, with developers representing 28 different organizations contributing code to its release. Subsequent releases are roughly every quarter. Now we come to next steps for continuing your blockchain journey. Whether you're a business stakeholder, a solution architect, or a developer, there are options available for you. If you're a business stakeholder, then you might want to turn your blockchain discovery workshop to talk to our experts, and the link you can see on the chart. Likewise, if you're a solution architect, you might want to learn more about use cases and references for blockchain, or join an existing blockchain network, or even discover more about existing solutions. If you're a developer, maybe your solution. Sign up at the link below and try out the IBM blockchain platform today. In summary, we've seen that Hyperledger is a Linux Foundation project for building blockchain technologies for business. And we've also seen that IBM Blockchain Platform adds build, operate, and grow capabilities on top of the Hyperledger Fabric base. IBM Blockchain Platform can be deployed in many different environments, from multi-cloud or SaaS to on-premise. And IBM is helping customers throughout their entire blockchain journey.
Okay, with this, the basic concepts of IBM blockchain has been done. And the one thing is, one final thing which I want to mention about this blockchain is there is a concept called smart contracts. What does a smart contract means? Depending on the previous contracts, some of the rules using the AI, they are establishing these contracts, and they are going to be present inside the contracts between the companies. So what it does is it automatically going to suggest some of the contracts, and these contract and the suggestions that we're providing, like these contracts are called smart contracts. That is also being done using the blockchain. One of the part is happening inside the blockchain there. So with this, I conclude, and I don't know how far you guys felt anything. I hope this is a good introduction for what blockchain and what are the different industries that are trying to migrate to blockchain. And yeah, thank you, everyone.
Thank you, sir. Sir, I'm open to take some questions.
I'm sorry, your voice is muffling.
Hello, sir.
Hello, can you hear me?
Yes, sir. Am I audible to you, sir?
No, I mean, you can, but it's kind of muffled to me.
Hello, sir. So, am I audible to you now?
Yeah.
So there are some set of questions which students wanted to put in. So I'll just we'll have a small question answer session. Girls, if there is anything, you can put your questions in the chat bar, chat window, wherein sir would look into and answer you guys. So you're open to put your questions in.
Okay. Okay, I'm seeing a couple of questions here. How does blockchain helps in education system? So, I mean, the one way which I can think how it can help education system is by having the transparency of a number of seats during the admissions and the fees that are going to be open. And if there are sometimes some of the people we approach through some of the PPOs, and there will be something promised and something was not going to be done by the, I don't blame anything there, but having these middle layers and all those things, it can be avoided there by using the blockchain there. And the next one is disadvantages and some disadvantages of blockchain. So the main disadvantage of blockchain is altering of the data whenever we need is not that easy. So let's say some error happened during the initial publishing of the data happened, and already certain blocks of data post that error has already happened there. So if we need to correct that error, the next set of data already all has to be, let's say in our regular terminology, it can be as an recompiled or everything has to be cleared and restart of the transactions has to happen into the blockchain there. So, okay, the next one is I'm seeing whether we can start some of the small projects like that. And inside this IBM link in the third video, they said that we can start using their how IBM as an providing solutions, and we can play around on the IBM website of this blockchain, ibm.com/blockchain/platform is where I believe they were offering some of the developers can join there and start developing or testing there using IBM platform there. And the next one which I am seeing is Bitcoin is one application of blockchain. How does it support the current economic crisis? So I don't think there is any direct relation of blockchain to the crisis there, but what my understanding was, economic crisis happens due to different level of things that are happening across the globe. But what it can impact during that crisis is avoiding the middle layers. And the next question which I'm seeing here is, blockchain helps in security purpose, security in the sense defense services. So I don't think, I mean, my understanding for the blockchain is not anywhere related to any service there. It's a technology that is going to be maintained across different applications for each individual transaction that is going to happen between both the parties. So it really depends on how they were configured for that particular service or particular department is going to be matter for the security purpose. The next one is, so what exactly do we concentrate on for AI and blockchain technology? So, I mean, to my understanding for the AI and blockchain was one biggest advantage was towards that smart contracts, which I mentioned. So what happens is using the AI, it is going to be continuous learning effect in the back end. The AI is going to learn what were happened with the existing ones and what were modified due to the errors or like those kind of things, and introducing them into the future ones are the ones that I can think of there.
Girls, are there any more questions from your end? Girls? Sir, are you there, sir?
Yeah, I'm here, Anish.
Yeah. Anybody else? Probably yes, that's done, sir. There are quite a number of questions, basically. So
one thing is, I know you guys are all confused right now because you guys don't know what we need to select as moving forward as the career and all those things. So one thing which I can tell is it can be AI, it can be data, or these are the evolving things right now in the industries. And especially blockchain came into the picture, especially with the Bitcoin there. But the only thing is there are multiple things where we can concentrate and we can continuously, but coming to the AI, it's a starting phase of AI. And for any company, data sciences, data is the primary key for each individual company there. So that's a suggestion, but these should be a booming technologies as moving forward.
right, rightly said, sir. So thank you so much that you have put out your time and on. I guess it's 8 o'clock at Sunday evening for you. Sunday 8 and yeah, it's
11:30.
11:30 at night. All right. Thank you so much that even in
No
the
problem. No problem.
yeah. Thank you, sir. It's been good listening to you and looking forward for a few more sessions of this kind. Because by probably yes, a 1 hour session would not be sufficient for the students to understand what basically blockchain or AI is. So it takes time even for them to understand. So once again, thank you so much on behalf of Stanley. Thank you for being with us, sir.
Thank you very much, guys, and have a great future ahead of time. Thank you.
Thank you, sir. Thanks a lot.
Thank you.
Sujoy sir, am I audible to you? It's PRM. Hello, Sujoy sir. Am I audible to you, sir?
Yes, you are. Hello. Good morning.
Good morning, sir. Can you please share your video?
Yes.
Mute yours. Mute yours.
Can I see?
Yes, sir. I can see you now.
Okay.
Okay. Good morning, everyone. For this session, we have Mr. Sujoy Roy Chaudhary. He is a group manager and senior data scientist in IBM and leads the recommendation systems and deep learning practice in IBM's AI services unit. He is a member of IBM Academy of Technology, which is the IBM technology leadership group globally. He has 16 years of experience in analytics and data science. He is a recipient of Major Outstanding Technical Achievement Award, the highest individual technical achievement award in IBM, and has been the best IBM awardee in 2019, given to the IBM's top performing 1,000 employees globally. He has co-authored 2 HPS cases and has 8 international conference publications, including 2 paper awards. He has been a visiting faculty at IIMs and given talks in various industrial and academic conferences. Sujoy sir is an electrical engineer and did his EPGP from IIM Bangalore in 2012 to 13 and is currently doing his PhD on speech recognition in AI systems. Good morning, sir. We welcome you to our session and we're glad to have you here.
Thank you. Good morning, everyone. Can you hear me?
Yes, sir, you're audible.
Okay, cool. So, just give me a minute. Let me know if you can see my screen.
Yes, sir. It's visible.
Okay. So good morning, everyone, and thank you for giving me the opportunity to give a talk on this topic. So I think for the last couple of days, you've been hearing a lot about artificial intelligence and its applications. I would look at a very small, from a domain perspective, one may think that's a very small domain, and that is fashion domain. But surprisingly, it is a domain which um, where AI has been quite successful. Uh, there are a couple of reasons for this, and we will go through these reasons as we will go through the talk. So we would focus on the fashion domain. Um, Again, if you have any questions at any point, you may ask me. You need I'm free for. Please feel free to interrupt. And the other thing is, we- if you if you have any other questions which are related but not directly to the fashion domain, please feel free to ask. I'll try to see if I can answer or not. So, I'm using a term by noted computer scientist Andrew Ng. Uh, AI is the new electricity. This image that you see on the left hand side is an image from 1910, just above 100 years back, from New York City, right? And at that point of time, people um, did not have electricity. There were a lot of questions about what is electricity, is it safe or not. If you look at New York Times and London Times at that time, you would see a lot of cartoons on people having strange fears about electricity, that it will burn everybody up, you will get entangled in wires, etc. 20 years from then, electricity was the norm all over the world. We are arguably at the same position in artificial intelligence. Everybody talks about artificial intelligence, but there are lots of unknowns. People don't understand what it is, what it will happen. The last two industrial revolutions, some people say three, but I prefer two. The first industrial revolution is in the 1760s, which was the industrial revolution for the steam engine. And then the second major industrial revolution was in the 1880s, 90s, which was electricity. The first two industrial revolutions replaced human physical labor with mechanized labor, automated labor. This industrial revolution, which is going to start, which has started and is going to take place over your career time. You are in college now, you would be working for the next 30 years at least. So this is the industrial revolution which is going to happen over your period of in your career. And this revolution is the one that will affect you most directly. So it is important that whether you are working as a data scientist or you are simply a consumer working in some other domain, right? You need to understand and appreciate some aspects of AI. This is like saying that is there anybody who can today live without electricity? I mean, that's practically impossible, right? In a similar way, during your career in the next 30 years, artificial intelligence is going to become the important thing in every domain, in every industry, in every functional domain. This is given. Whether whether we were how good it would be, we are at very initial stages. How good would it be? People do not know. Those are questions which are difficult to answer, but there will surely be impact of artificial intelligence in every domain. Now we will focus in our talk on a very small subsection of the consumer retail domain, and that is the fashion domain. Let's look at some broad level use cases. I've worked on a few of them myself over the last few years, and I'll go into some detail about them. But the first one, visual browse. Now, you would say that this perhaps exists today in many apps, but the question is, and we will see an example, a couple of examples, that it is only artificial intelligence enabled underneath, that when you are browsing and looking at similar products, these would be very relevant only if you have good artificial intelligence search, and um, uh, and uh, and closely related to it are two things. One is visual search. So you upload a picture of an image of let's say Hrithik Roshan or Amir Khan, and you want to dress, want a shirt like that, or Priyanka Chopra, a dress by which she is wearing, and you want a picture related to that. This is something that I did for one of my clients in one of the fashion domain retailers in India. I'm not sure whether it's still open to consumers or not, but how do you do that? How do you find similar products? For that reason, you need to build it. You need to build it based on AI. Natural language search. Today in Amazon or Flipkart or Myntra, I'm sure all of you use that. If you go in and search, I want to look at a top, right? A black top, right? You will see there are lots of tops. But how do you sort of uh, add information? Can you look for a black top which has a World Wildlife Federation uh, logo? Can you look at a top which has you've liked a certain text, uh, and you want to see whether there is a top with that text or not, right? That sort of thing is what AI can enable. Complete the look. It's pretty obvious. You're looking for a top. Can you get a jeans corresponding to that? Can you get shoes corresponding to that? And we'll see an example of this. Substitute recommendation, very similar. How do you recommend products for products which are out of stock? That's the experience part, right? Here is where we would look at the experience. This is the one which is more common to and what you get to see as an end user. On the right hand side is the creative AI, right? Can you look at what are the trends today in the market? One of my clients, in fact, the same client I just now talked about, a couple of years back, wanted us to get to recommend products based on what are the current trends, right? Can we enable that? Can we take data from social media? Can we take data from fashion blogs, parse that data, curate that data, and understand that today, for example, in South Korea, there is a very hot trend of couple matching T-shirts, right? Can you understand that such a trend is happening? Can you understand whether distressed jeans are in trend or not? A sales analysis more traditional. I won't go much into depth about that. Here's the most the the three here: color and trend prediction. When we are talking of trends, can we talk of colors? Can we say which colors are trending? Can we use that to build prints, right? And therefore, we are no longer only using AI to sell. We are using AI to generate, right? I will show you one small IBM video. This is one thing that I've personally not worked on, but my colleagues in IBM has worked quite a lot on, is building using AI to create new designs, right? Creative Kuta. And so all of these, and then e-catalog enrichment, that's a back-end job which helps you to do natural language search. But what I want to point out is that these are so many use cases. Now, I just want to mention fashion is a domain where if you are looking at AI publications, even in the top conferences in artificial intelligence, you will see that fashion, there are lots of use cases on fashion. But there are two reasons for this. The first reason is that fashion is very data rich. It is data rich, lots of images, lots of text, excuse me, lots of public data available. That is one huge advantage, and I know over the last 2 days, and I'm pretty sure many of you would know that AI is based on data. That's the first. The second thing about fashion is that, unlike, say, medical domain, or unlike, say, supply chain, right, especially medical domain, the cost of a mistake in fashion is less. What would happen if I recommend to you a wrong product? Practically nothing, right? But what will happen if I recommend, if I give you a wrong medicine? Human beings can die, right? If I recommend a wrong product to you in the financial domain, you can lose thousands, maybe millions of dollars, right? If if I make a mistake in manufacturing, say in a car manufacturing state, right? The entire assembly line, which costs millions of dollars, can break down, right? So there are lots of challenges when we are talking of many domains. But fashion is a domain where the cost of an error being less, we have been able to use some of the latest and the fanciest techniques successfully, but without the inherent risk. Now, let's take one example, and let's try to see what happens when you walk into an online into an offline store, and can we compare that with it online? So once you go into your store, a person from the store comes and talks to you, right? And that person actually has a conversation with you, tries to understand what your needs are, and tries to give you recommendations. That is not the way most traditional online, including Amazon and Myntra, etc., would work, right? You would go in and search, but if you think of it, you are not really having a conversation with a person. And I'll show you the difference in a small demo in a few minutes, or at the recorded demo. Then you would look at the person, and this person, and the salesperson would try and give you products which are more suitable for your needs. For example, uh, based on your body type, based on your age, based on your hairstyle, and all of these things, they would recommend products for you and what other people similar to you would buy. Then, so that is the place where we have a recommendation engine. And within IBM, we call this recommendence, which is combination of recommendation and artificial intelligence. They would also give you similar products. Is there a question from someone? Okay. So they would give you similar products. If you don't like one dress, they'd give you similar products. They would also give you top selling products, would say, this is trending very hot, madam. Would you like to buy this or not? And then they would give you the complete the look, right? Where they would try to get a sense of the fashion. Not everything would go with everything else, what colors, what combination of products, etc. What I want to tell you is that the final experience online will be similar to the offline store when we have all of these working in unison. We've worked with a couple of clients trying to enable it, I wouldn't say we are perfectly or we have been able to completely replicate the offline experience, but we have been hopefully been close. So this is when and you go in and purchase. Now quickly, what is a recommendation system? NA recommends products based on their past purchases, and most e-commerce platforms, and famously Netflix and Amazon, are built on very good recommendation systems, and YouTube also. Now, I would like to point out that a recommendation system is neither an advertisement. In an advertisement, there is a mass messaging via a medium, and you don't really know who gets to watch that advertisement. An advertisement on a TV channel, nobody knows who is watching it, but by looking at what is the profile of people who watch that channel or that program, you get to know what is some overall demographics. Campaigns are where the company finds out, okay, this group of people are more likely to buy full length dresses, and therefore gives and sends you an email or a pop up on your smartphone, giving you an offer, a product code, and hoping that you would go and buy there. And the reason they give you that product to to apply that code is to be able to trace whether that campaign was effective or not. A recommendation system is, however, personalized. Theoretically, two people on a recommendation system would not have the same recommendations, but at least the way you understand it's a recommendation system is that if you and I, or you and your friend who are similar to each other in many demographics, etc., if you go in and search, you would get different results, right? Now, I will not go into the full theory of recommendation systems, but they're based on one underlying hypothesis. Similar people buy similar products. This is a very important hypothesis. Without this hypothesis, recommendation systems don't work. Now, this is obviously not completely true, right? You may go ahead and buy something for your parents, and then or your uh, brother or something, which would be a product for men, and then, so that's one issue. You may like to buy clothes which are bought by people younger than you or elder than you. Those are always true, but what actually matters is on average similar people buy similar products. One of the older systems is based on collaborative filtering, and there are types of different collaborative filtering, user and item based, where you either see, okay, these two people have bought the same products. So if the second person has brought product C, then possibly the first person will like it. Or so these two people are similar. Here, these two items are similar, and therefore you recommend to it. There's a lot of theory behind it, a lot of maths behind it, and there is a lot of deep learning systems that are common today. I would not go into this overview talk of the technology and the solutioning behind it, although I personally love it, but I don't think it's enough to cover in an hour's talk. So similar people buy similar products, and this is how these systems will work. Now I'll just show you a demo. It's a recorded demo. I don't have it live, but this is a real demo, and it will show you most of the replicating offline experience quickly. So so here's a person, Erica, who is logging into the portal. This is a chatbot, right? It says, "What would you like to do?" And Erica asks, "Show me dresses." And now Dresses, of course, as you would know, there could be tens of thousands of dresses in a certain store, right? If you try to go ahead and buy that, if you try to recommend a dress out of 10,000, 5 out of 10,000, it won't work, right? So now you try and bring it down, and you bring it down in an intelligent way, in a way that that is able to cut down your product the fastest, so that you can, in the least number of questions, you don't want to answer 30 questions, right? You're not doing a survey, right? So you would like it to be quick, and so we use some entropy based, Shannon's entropy based calculations under the hood, and we ask what is the look that you want. Now remember, look is not a product attribute that is directly in the product metadata. And you would look at, say, party, and then this lady says that I want satin, and then you will get a number of products which you would be able to visualize, right? And you see you can buy on one of them, uh, and then once you come here, this product would say, this is where we say the fashion sense, these are the products which would go well with this, and this is how your system would work. Now, if on the other hand, a certain different person, that's what I want to show you in this demo, is that a certain this different person comes in and asks um, for products, the way it would be coming up is different. So I'll just skip the rest of the demo here because it's the same thing. But what I want to show you is that by this approach, and this is of course a demo setup which we have done uh, uh, for our clients, but this is actually being implemented for one of our clients in South Korea, and this is the use case summary. It is so the front end is different for the client, but and it's also in Korean. Is one of the is the top retailer in South Korea. Well, their biggest store is a 14-story store in Seoul, and what they want is to understand customer questions via image text and provide recommendations. What are the pain points? Is that traditionally, when we were looking at, they were doing generic mass marketing. But can you build recommendation systems? As I said, not campaigns, but recommendation systems where it is customized. And there are too many clicks, and then this is what they wanted to remove this. They are a marketplace, and they would want you to choose between different brands, compare between different brands quickly. And here is one question: summer socks would return products either with summer or socks, but really you want something else. And how do you understand these concepts? So when you build any recommendation system, you will have to relate between the product and the customer. Now, what is the product? The product is not just the product's physical attributes like material or color. It is other information um, like how old is the product? Is it a trending product or not? Uh, any, of course, pricing information. Who are the people who are more likely to wear? And then when you add AI infused things, is there a celebrity who has endorsed such a similar product or not? Is there a trend today currently on this product by looking at fashion data, blogs, etc., or social media data? And then is this, if you want to wear a shirt for an interview, right? What is that? What does that even mean, right? If you're wearing something and you're going to Chicago in winter, now that's very different from winter in Hyderabad, for example, right? So you want a jacket for winter jacket, but it's very different. The jacket would be extremely different whether you want it want it in Hyderabad, Delhi, or Chicago. Correct. Then when you look at the customer, some of these are obvious demographics, etc. But here's the one that I would like to point out: digital wardrobe. Can you get the customer to say not only the history that she has bought from your store, but also ask them, can you give us some products, that similar products that you have? That's when you start looking at your competitor data in a non-intrusive way, and still use that to recommend your product. Here is the Indian client that we worked with. They had very similar problems, but they were one step ahead. They wanted to say that how does one search with respect to floral print shirt, for example, or can we use style trends from our competitors? Can we look at our competitor data, their images, and understand that? And that's what artificial intelligence is able to do by building recommendation systems which look at images also. So what we built was a computer vision based deep learning recommendation system. Again, I will not go into the details, but this is a very interesting work which we did, and it was very successful. And I like to bring out one point. When you look at product attributes, when products are launched on the portal, say for any marketplace, or even for the product of a certain own brand, the products have attributes built in them: color, size, etc. But not all of these attributes are really these attributes are not really useful because of three different problems. One is insufficiency, inconsistency, and incompleteness. And let's look at each of them. 75% of products have at least one relevant attribute missing. What is a relevant attribute? It could be color, it could be fabric in a fashion domain, it could be collar, sleeve, etc. 75% of products have at least one relevant attribute missing. Now, if you have 1.5 million products, you cannot do it manually. You need an algorithmic solution. So we used a couple of different approaches. We used computer vision to predict, can we say whether this shirt is a half sleeve shirt or a full sleeve shirt? Can we predict what is the type of the collar of this shirt? So that's the one approach which we used. The other is the products themselves have a descriptive text along with it. Can we identify some things from there? The other problem is understanding color. And can we instead of using a color like yellow, or some shade of yellow, some shade of blue, teal, right? Teal and blue are more similar to each other than teal and yellow. But if you just use these words, then you don't have that information. So what we did was we took these products, took the images, and identified the RGB color of those images, right? The most prominent color in that, the top two prominent colors in that dress, and used that to be able to understand the products. Now here's the quick part of inconsistent. This is real data. I will not mention the website, but this is real data. Just look at this. Visually, do they have a much difference? Very little, if any. heathered, pattern weave, solid, textured weave, right? And here there is Dobby, textured, embroidered, printed, jacquard, washed, right? All of these are, even if I ignore the washed part, they're practically the same, right? And all of these are actual data from one product of shirts, formal shirts, and we have so many varieties. So there is this inconsistency. If I'm looking for textured, I also want to look at the printed ones. How would I know that? So that's one issue with textual attributes. And then checked and checkered, right? This is purely a nomenclature problem. And then the other issue is attributes that are insufficient. These are both printed. If you look carefully here, you would see there is a light print here, and here if you see there's a bright, very colorful print. But these are both printed shirts. This is from a website, but I'm not criticizing that website. It's a problem with any website. Both of these are checked t-shirts. What you can understand very obviously is that when I am looking for a t-shirt like this one, I won't be really happy if I'm looking at a similar product for this one. I won't be very happy if I get this. Or if I have this one and I don't be very happy if I get this, or the other way around. So there is more information than that textual. So what did we see? We saw that attributes are number one, incomplete. 75% of products have at least one attribute missing. There are roughly 8 to 10 attributes per product in a fashion domain. Then they are inconsistent and they are insufficient. So what it comes about is, can we use artificial intelligence to take unstructured data and make those recommendation systems better? So here is what happens when we look at similar products and I'm doing visual browse. If I do not have AI, these are blue shirts. If I have AI, then these are your recommendations. I would say, and I hope you would agree, that this is perhaps a closer match of similarity than here. So now I'll move into this video. This is on. Let's look at this video for it's about 2 to 3 minutes. And this is really cutting edge AI in design.
I want them to see a woman that's strong. My name is Jason Gretchen. I'm a fashion designer. What I do is just give them a second skin.
I hope you can hear the audio. Hello?
Sir, we're able to watch it, sir.
Can you hear it?
The audio is not pretty clear, sir.
Okay, let me do one thing. One second.
I want them to see a woman that's strong. My name
is the audio better now?
If you can play it.
Jason Gretchen. I'm a fashion designer. What I do is just give them.
Is the audio better?
Comparatively better, sir, than before.
Okay.
A second skin. We used textures like silks, and we used nice soft things. We had the studs, or we had really beautiful pearls and beads to that. So it looks soft, but when it's worn, it's, hard.
IBM Watson is a cognitive system, which means it can interact naturally with humans. With Watson, we were able to analyze 10 years worth of fashion data and then present Jason with a color palette from which he could select colors for his new spring collection.
So Watson predicted color palettes, and the colors were generally pastels. So the initial thoughts were, wow. It was really hard to understand that something so interesting could possibly turn fashion on its head. What I've done in the past is take risks with colour. You sort of design what you love, but you also have to design what's commercial, because we're in a business and we're in a business to sell. Watson's allowed us to have more direction and allowed me to do things with more ease and confidence.
With Watson, we used our visual discovery capabilities to help Jason analyze photographs and to compare and contrast photographs of architectural elements with trends and features in fashion.
Architecture is amazing because it's a 2D drawing that becomes a 3D form, and that tool was amazing.
So with Watson, we're able to do personality insights of an individual, and then we're working with a designer to understand how does that change the design process.
What Watson's done is allowed us to look at things with a different point of view. So we've made dresses with lots of layers, really nice deep V-necks, really amazing soft skirts. I've designed 12 different couture dresses, all aligned with the recommendations made by IBM Watson. Melbourne Spring Fashion Week's an amazing event, It gives us this really great platform.
Melbourne Spring Fashion Week's relationship with IBM has been running now for 3 years. It essentially started around data, and it has...
I'll just stop here, but what I'd like to point out is that there is some work, although this is more experimental, there is some work today on being able to use artificial intelligence in product design. Now, this is a virtual try-on. Now, what I would like to mention is that this image that I have is not a real thing. I cannot display the actual demonstration. But if I have one picture and you are looking at, say, hair color or lipstick or foundation color, how would you look with that foundation, right? Can you use artificial intelligence to apply that foundation, etc.? Again, this is based on understanding, using computer vision techniques, what is the current color of your skin, how would that color combine with the foundation color, and be able to predict that. Also, how would light effects, etc., on your original image affect the way you would look at it? So that is what what artificial intelligence can do, and you can therefore play around with many different hair colors, lipstick, and foundation, and basically, if you have let's say 30 each, you can go ahead and choose all possible combinations of them, if you have the time, and see which one you look best on. And that's something that you would not be able to do in an online store, in a physical store. Here is something which, this is not something that we worked on, but many of our, but we worked on similar products. This is already available. This is also based on artificial intelligence, by trying to estimate your eye shape and then giving you, this is on their Lenskart website, giving you the product. This is another YouTube video. I'll just quickly spend a minute on this YouTube video before we we open up for questions. I'll just spend a minute on this because I don't want to spend.
I'm looking at 3 identical ladies.
This is where virtual reality and artificial intelligence come together.
Each one is sporting a different piece of streetwear. And it really feels like they are in the room with me.
I'm wearing the Magic Leap mixed reality goggles, which overlay computer images onto the real world. The college wanted to explore how we might one day use mixed reality to enhance our online shopping experiences. And this app was the result.
This really is so much better than looking at photos of clothing on a website. You really get a sense for how the material hangs and the quality of the fabric too.
Return rates for online shopping are over 60%. So the possibility of trying clothes on virtually before you physically have to do that will make a huge difference to consumer experience.
This could certainly be a better way of shopping for clothes online. Of course, what would be good is if it wasn't an avatar of Martina here wearing the clothes, but an avatar of me.
Which is why I find myself wearing my brightest and tightest clothes while my curves are being scanned by a phone.
Capturing 3D content for fashion in the past was either incredibly difficult with hours spent in front of a computer 3D modeling, or very expensive using vast camera arrays. What we are beginning to get towards is the possibility of capturing photorealistic avatars through a smartphone.
You do still have to stand absolutely still for several minutes, all the time remembering what my mum used to say, blue and green should never be seen. And then there's several hours of processing online, but finally, here I am. The same method is also used to capture clothing items. The idea is that clothing companies will scan all of their garments in all different sizes, which you can then pop on to your digital double. But the team here think this application will go far beyond online shopping. They're looking to a time when we'll all have a presence in the digital world and we'll want our avatars to meet each other looking their best. And not only might there be a market for these completely virtual outfits, but one day we might also be able to augment our actual clothes back in the real world.
We truly believe what's called the AR cloud is...
So, in fact, I have done a very small POC on this couple of years back on trying to use a camera from different angles, understand the body shape of the person, and then using standard body shape structures, being able to overlay products on them. All of this work is a bit futuristic, but this is where we would go to. So I started off with saying that replicating the offline experience in the online world, I won't be surprised if 10 years from now, someone talks about replicating, maybe 10, maybe 20 years from now, someone or maybe me myself would be giving a talk on replicating the online experience in the offline world, because really the online experience can be very different once you start adding computer vision, natural language processing, artificial intelligence. You can really get a completely different experience. So I will stop here and I will open the floor for questions. Any questions from anyone?
Hello, sir. Girls, if there is anything, please you can, if you're not able to unmute yourself, please you can use a chat bar. So there is one in the private chat. There's a student who asked whether, sir, as we are coming out as a graduate student, like how do, we also have a passion towards fashion, but then we never know how do we integrate, because our final jobs are only on terms of programming and traditional working model.
So one of the things that you would need to understand is that if you are looking at some of the, there are two parts of it. One is one is that in the fashion domain, it is not only the data scientist who works, because the other people are also creating great and very important input, like the people people who are the designers, people who are your business analysts who analyze the data, etc. So that is one part. The second is that to build and deploy the AI models to production, you would need the entire software engineering to come in, like your at the minimum your data engineering pipelines, where you would be processing the data for the AI models to use them, as well as the DevOps processes where you would be deploying and maintaining these models in life. However, if you would like to get into the core or aspects where you would like to combine AI and fashion, that point you would need to have a background in the data science models. And some of the ones that I showed you are very cutting edge and very latest. But then there is others where you would be using more traditional AI techniques, for example, collaborative filtering, to build systems and deploy them into systems. So if you want to limit yourself to software engineering, then the other areas, related areas like data engineering and deployment. But otherwise, if you are interested in systems, etc., then that you would. But if you want a in-depth AI background, then you would need to have some background in AI.
One question in the chat window from Zuha. She's asking how to proceed if you want to pursue a career in fashion related to AI.
Well, when we are saying that you want to fashion related to AI, is it more on the fashion aspect or on the AI aspect? Because for AI, you would need to have a full background of AI. If you are more interested in the fashion part of it, you would need to work in cutting edge technology companies or in fashion companies which use AI. And remember, their inputs are critical for us to build AI systems. My knowledge of fashion ends at shirts and jeans, so that's about where I go to. And but I've been able to successfully deploy 3 solutions into production uh, related to fashion AI. So yes, domain knowledge is very important.
This is another question from Tasneen. When AI gives recommendation to people on a particular website, can it happen that one brand is being recommended more and thus earning more just because of recommendations?
Yes, that is a possibility. And this is actually a problem that happens. There Now, is this a good or bad thing is a little complicated. There are two parts of this. The first part of this is that if a brand is doing better, then that brand should get recommended. That goes without saying. But the twist in the tail is that there is a vicious cycle. If a product does not get recommended in the online world, then that product does not get sold, and therefore it does not get recommended even less. This is a problem which you would see in recommendation systems. It is basically a vicious cycle which can go on and on. Uh, are there ways in which we can handle it? Yes, we do. We do take care of situations the where the system is uh, accounts for the fact, for example, that if you are a new player, then your sales would be less. So therefore, those are accounted for in our calculations. And the other thing is there is mm, some work on being able mm, to use AI for but irrespective of this, this problem exists, and it is not only in the fashion domain. It exists in many other domains. I'll quickly take 1 minute to point out a very related problem. In 2016, when in the US elections, the results was unexpected by some quarters. The reason that happened is that for many people, when you get a recommendation on your Facebook feed or your Google News feed, you would be looking at a certain political view, and those are the ones you would click on. And because you click on them, you get more news related to that, and therefore you tend to forget that there is another world. This is a problem in AI systems and recommendation systems. It's I will not say there have been no progress to solve this, but whatever progress exists, it's early days to solve it in a good way, and we don't even know whether we should actually solve it or not. So there are it's an interesting problem. Yeah. Okay.
There's another question in the chat window side. We are getting it on the private chat. It would be better if students put it over the public chat, but then the question says, like, so we basically, whenever we go out for shopping or we see brands, there are other what is that word she put? She says the actual meaning of the question was, sir, she wanted to figure out, like, Puma being a branded company, there is somebody who replicates it with a small logo change, or probably in the name is very small change. So how does AI support in identifying who is the original one and the duplicated one? That's what she meant.
Yes. Okay. So first of all, counterfeit identification and identification of copyright violation are very interesting problems in AI. We are able to use computer vision techniques to be able to see whether these things have happened or not. And so this is a possibility, and it is quite commonly used to identify fake brands, fake products, etc. And not just here. I mean, fashion products is fine. I mean, what about counterfeit medicine? Right, that's also a real problem, and it could be extremely dangerous. So yes, this is there. As to who is the copy of whom, it is based on some reputation metrics that we use, but and what is first registered. But in the way that yes, this is possible and is quite commonly being used by almost all of the e-retailers in India today.
Thank you, sir. And so there's one more question. There's a student asking about, so as we know that you're from IBM, we wanted to know, as an entry-level entry level graduate, how long would it take to prove ourselves as an AI expert?
Well, if it is about the fact that once you would have to go through certain courses, etc., and you would need to show that you do know AI. It's not about a matter of time. It's about how much effort you put in. What are the sort of both formal education you take, as well as other online courses that you take, and the fact that you are able to actually work on some projects of your own and prove your worth. So it's not a matter of time. I've known people who've moved in a year. I've known people who would like to do it for years on end but have not been able to. It's about the amount of effort, the amount of hard work you put into the topic.
Any more questions, girls? If you would like to talk to sir, you can unmute yourself and or you can put it over the chat window. There is one who is asking that, sir, can you share your presentation with us so that it would be a reference or a recap for the session again?
Yeah, I'll be able to share. I'll just delete the demos what I had shown, but the rest I would be able to share. Yes.
I guess that's about it, sir. I have no questions in the private window as well.
Okay. So thank you very much.
So there's one student again, Sai Deepa Reddy.
Okay.
A student to understand in which field I want to work in with AI knowledge or internships the best choice.
Sorry, I did not understand the question.
The question was about as students to understand in which field I want to work in with AI knowledge or internships the best choice.
Are internships the best choice? Internships is of course a good choice. I mean, no doubt about that. But then the other question is, how would you get the core AI knowledge even in an internship, right? For that, you would need to do some coursework, either in your college or in further studies, as well as online coursework like MOOCs, etc. So there has to be something thing, because remember, that a lot of AI is quite different from the way you would do your traditional software engineering, right? So that is one thing that you would need to keep in mind. But yes, internships are a good place to start.
There's one more last question, I suppose, in the private window I got it. There's a question that is asked, like, seeing the current scenario with the COVID time, how we as a student can approach for internships now? How is it going to be? How is our career going to be? Because we don't find anybody helping us out at internships currently.
This is a difficult question. I'm not personally involved with at least undergraduate internships, so it's difficult for me to say. And whether COVID has affected it or not, I'm not very sure. So I'm sorry, but it's not something that I am personally well aware of.
Yeah, so that's about it. So currently we got only these. Girls, sir would be sharing his presentation as said. Probably I can share it with you guys in the evening today.
Yes, surely.
Yeah. So thank you so much, sir, that even after having a busy schedule, you pulled out time for us to interact with our students.
No problem. Thank you for the opportunity.
Thank you, sir. Thanks a lot. Looking forward to have you in our future meets again, sir.
Okay, thank you.
Thank you, sir. Thanks a lot. Thank you, sir.
Have a good day.
Thank you, sir. Wish you the same as well. Girls, we'll be having a half-an-hour break, after which we have Prasanna Lakshmi ma'am, who is from Broadridge Company. She's a product manager over there. So yeah, she'll be sharing her expertise with you guys. So please make sure that you are 5 minutes before 10:30, please.
Hello, ma'am. Lakshmi Prasanna, ma'am, are you there? Hello, ma'am. Ma'am, can you hear me? Ma'am, we've made you the co-host. You can unmute yourself, ma'am.
Okay, hi, hello, can you hear me?
Yes, ma'am, we can hear you clearly.
Okay, 1 second. Let me increase my volume. You're able to hear me, right?
Yes, ma'am.
Okay.
Ma'am, but we can't see your video.
Yeah, I am not shared yet.
Okay.
1 second. Can you see me?
Yes, ma'am, we can see you now.
Right.
So, hello everyone. Now we have with us Ms. Lakshmi Prasanna. She is an IIM Bangalore alumni and PMI certified project management professional and certified lead safe agilist with around 15 years of software development and management experience. Currently working as a project manager with Broadridge Financial Solutions India Private Limited. She manages projects delivery for various brokerage operations clients primarily from UK and US. She has done MCA from Andhra Mahila Sabha, Usmania University, and Executive General Management Program from Indian Institute of Management, Bangalore, and Executive Technology Program from IIT Hyderabad. Currently, she is a Deputy Director for IIMB Alumni Hyderabad chapter, leading the chapter activities. A PMI volunteer and a part of the core team, which is mentoring tribal girls and helping them groom into digital leaders. Associated with Vidyalok as a teacher, volunteering teaching students over Skype in Telugu medium. She has delivered a few guest lectures for academia, received a gold medal for many academics in MCA and Women Leadership Awards from Telangana Best Brand Awards in November 2019 for contribution of CSR activities done on behalf of IIM Bangalore Hyderabad chapter. We welcome you to the session, ma'am. We're glad to have you here, ma'am.
Yeah, thanks Purvi for the nice introduction. And good morning all of you. Am I audible or do you want me to have a headset?
No, ma'am, you're audible.
Okay, just a minute. Okay, so I think it has been a very knowledgeable and insightful weekend with so many guest lectures, speakers, lines. So you must be having got good insights on what AI is all about, right? Yes. So first I would like to thank Stanley Management and Professor and Convener Anisha and the team about Big Dreams for giving me this opportunity to share my experience or whatever knowledge I have on AI. To be honest, I'm not an AI expert, but have some little bit of hands-on and worked on few areas very long back. Right? So I'm just here to share some perspectives on AI and hope you will have some key takeaways at the end of the session. Okay.
Sure, ma'am. We're definitely looking forward to hear you speak.
Thank you. And also, I think earlier also I mentioned to some of your students, like I really like this team name, Team About Big Dreams, because you should always have a dream to achieve, then only you'll grow. And that's all my role model, Abdul Kalam, Dr. Abdul Kalam, he also always talks about dreams, right? And this getting the event organized, itself talks about how you're planning to achieve your dreams, right? It's not a mean task, right? When I looked at the speaker lines, the topics and whatever organized way it has been done, it's not really very easy, and that too virtually. And you girls have done it. So congratulations and well done, girls.
Thank you so much, ma'am.
Keep up all this enthusiasm and okay, right. Now, yeah. And I looked at the speakers, the topics. So I think pretty much everything is covered. And I being on the third day, of course, I have chosen that. But it was a little challenge for me to choose a topic that really interests you because I think most of them are covered. And I think today's morning session was on AI in fashion, which is a very interesting topic for all of us.
Yes, ma'am. Just the session before this.
Yeah, I know. So to keep up that momentum and to keep up that interest, I was just checking what should I cover. Then with the recent COVID, whatever is happening in this field and all that stuff, I thought I'll just talk about a little bit on what is scaling, AI, artificial intelligence scaling, right? And then we will see what is the prominently, there are few areas where we need diversity, right? And contribution of women in this area. So my main theme is about scaling AI, and the other part of the session will be primarily on diversity factor, because which will be more relevant to all of us, since that everything is covered. So I thought I'll cover these parts. Okay. So we'll move on. I'll share my slides. 1 second. Can you see my screen?
Yes, ma'am, I can see it.
Okay. And in between there could be connectivity issues, maybe just bear with me because of the power cuts. You know, we are all working from home and there are some challenges in terms of all this infra. So just bear with me in case if there is any disconnect in between, and let me know.
Sure, ma'am.
Yeah, okay. Well, we'll start now. It's AI at scale. Now that you know what is AI, I just want to first start with how AI, and I think earlier sessions there were two topics covered, past, present, and future, which talk about AI, right? What's the past and present and future?
And future of AI, yes, ma'am.
Yeah, right. I just want to kind of, and also how data science is helping, how machine learning is helping, all the stuff. So I just thought we'll first quickly recap what you have done just in a couple of slides, and then we move on to the topic of scaling, right? So this is the agenda today's, what is AI evolution in brief. Then we'll talk about what is AI at scale, what is this diversity factor, and what are the contributions of women in AI. So these are the topics that we would like to cover, okay? So first, I think you must have got a good grounding from the past 2 days on what evolution is about, how AI is evolved. So fundamentally, it's a very old concept, nothing new. So it started right from 1950s, where it just, they just started on it, and then developing some very basic models and working on Excel sheets with limited data. And then from there, it moved on from this area, in this phase to machine learning. And from there, it moved on to deep learning. And now you have neural networks, and so many advancements have happened in this field, right? But again, no matter what technologies will come up, no matter what programming language comes up, still the fundamentals would still remain same, right? And many people are using artificial intelligence in machine learning altogether, but that is not the case. Artificial intelligence is an area where these are all various paradigms that we have in it that we'll look at in next few slides, okay? Right. This is the one main crux which I thought I would cover, which will summarize what you have learned so far. This is called AI Knowledge Map, which covers the entire AI. What are the various paradigms and what are the associated technologies with each of these, right? So this is an area where we have different method, paradigms or tools or areas, whatever you call. One is logic-based tools. The other set is machine learning based. The another one is probabilistic method. The other next two are embodied intelligence, and the other last one is search and optimization. And when I look at, whenever people say AI, generally this is the one that comes to our mind, machine learning, because the name has become so catchy that everybody talks about machine learning, and that is what AI is all about. But that is not the case. If you look at, these are all areas where AI, all the areas belonging to AI. Okay, and now you might have known all this. Some of them are very familiar because the machine learning, supervised learning, unsupervised learning, and we also talk about frequently about NLPs, natural language processing. We also talk about computer vision, and this one, autonomous system. These become very prominent amongst all this. It's not that the other are not there, but these become very prominent when we keep hearing this, right? So when I say logic based, these tools are basically used for problem solving. Okay. So for example, robotic process automation, this one is used by having some rules and then deriving at some actions on that. This is a robotic process automation where you will have the user to perform and then the machine or the robot will mimic that particular user. That is the robotic process automation. Okay. And expert systems, these are the systems that have some hard-coded rules, okay, to kind of mimic the human decision-making process. These are the expert systems. Then coming to machine learning, we have different kinds of learning methods where machine will learn the data and come up with the solutions. So one is supervised learning, the other one is unsupervised, next one is reinforced, and the last one is neural networks. Okay. And under probabilistic method, the name itself says probability, so we don't have complete information in this case. So in those areas, we will use this methodology, and the techniques that are used are these. Natural language processing, NLP, you have Google Translator, you have many NLPs coming up now where they convert, understand, and then generate the destination language for us. So these are the NLP processors. Then we have computer vision, which will use the images and process it and produce the information for us. Okay, that's the computer vision. Then we have embodied intelligence. These are nothing but some tools that will, again, use the speech, hearing, all that, and then we come up with the solutions for that, like autonomous systems like self-driving cars, all those come under this category. And searching and by name itself, these are helpful in searching. And while searching, this kind of tool will use the science based on some of the techniques are based on biology, where you use the concept of mutation, reproduction, all that stuff. So in a whole sum, this is the whole AI, different paradigms and the corresponding technologies that we use. I think some of these already covered in past 2 days sessions. You can refer back. Okay. So it's on AI knowledge map. Then why AI has become very prominent now, like for last decade onwards, I think we hear this word more. Even while I was studying, I never heard much about AI, but now we listen a lot about more and we see more opportunities at this as a career, right? The reason being three. One, we have enormous data now, trillions in petabytes. You have, if you look at the data size is growing enormously across the organizations, across the systems. So that is one, exponential growth. Second, the storage cost is decreasing eventually. Earlier in 2000, when 1 GB was costing $12, $12.47, now it costs nothing. And this is made possible because of cloud technologies. The storage cost has come down drastically, so you can store as much as data you want and then build models on it. So that is why another reason. The third reason is the processing capabilities or the infra has increased tremendously from 10 power 3 to it's now like 10 power 7, and these are the stats of 2017, and now it has got much more increased. Okay, so all these reasons are contributing to AI, because AI, when it is built on a huge data, you get more models, more efficient models that would support the system, that would help the system, which will cover all the scenarios. That is why now AI is on the rise. Okay. Now, I just want to catch up on the trends that we have. It's not that because of COVID we have these trends. AI already have these trends prior to COVID, and COVID had a little bit more contribution to this COVID situation. So as per PricewaterhouseCoopers, AI products will contribute around $15.7 trillion to our economy. All AI products clubbed together, whether it is at individual level or whether it is an industry level, these products will contribute to so much economy. And another point I would like to make is earlier AI was seen as a discipline only for IT industry. It was limited to IT professionals, but now AI is being used across industries, which you have seen last 2 days, I think in fashion, in now I think next session is about image processing, and there are a few more sessions that I have seen. So here you don't really need to have the core fundamental technical knowledge of AI to build AI applications. And that is made possible by developing AI and machine learning as a service providers. Okay, so that you can use the APIs. You don't have to take the efforts to build the models, to understand the data, to build the models, to build the algorithms and produce a solution. They are all ready-made available, all these APIs, and then you can start using them. Okay, and that is what I'm meant here. AI as a service, machine learning as a service. And this includes all the bots, digital assistants, cognitive computing APIs, that vision, hearing, speech, all those APIs, machine learning frameworks to enable the supervised, unsupervised, all different types of learning, and fully managed machine learning services. Since we use Amazon AWS, so I just took a snapshot of what all services that we use here. If you can see it, Amazon Augmented AI, Code Guru, I mean, it will create everything ready-made for you. You just have to use that API and then plug in into your application. So it becomes that easy now with this. And how do I make this small? Right. And due to COVID, right, this has been contributing to forecasting consumer visuals preference, because now people are not able to move around as freely as previously. Everybody is preferring to online shopping, right? Online experience. This AI is contributing enormously in that area. And if you look at, right, if you purchase something on Amazon website, for example, the moment you purchase a product, for example, a mobile, anytime you log in, whichever website maybe, you still get a pop-up below that these are the next set of mobiles available, or these are the offers available. Likewise, you get so many pop-ups coming up, right? That is all done using predictive analytics. So once they know the consumer preferences, wishes, and the choices, they keep tempting you, showing this pop-up so that the consumer may get tempted to buy those. So that's one way of marketing, right? So in that area, AI is contributing. And also, once they know that consumer preferences and the buying patterns of that particular consumer, whether it is Amazon, Flipkart, any e-commerce website, then they can also plan the logistics, saying that, okay, this is a pattern, this consumer has brought these items, so we have to plan logistics for delivering that particular item. So that way it's helping even in planning the logistics. Then chatbots provide 24/7 service. If you log into any, for example, any HDFC Bank portal or Axis Bank portal, on the right side corner, you'll find a chatbot, right? Which will always help you 24/7. When you type a query, it will return back the answer, all that. And when you log in also, whether it will ask you whether you're a robo or whether you're a human, right? You have to enter the CAPTCHA code and then identify yourself. So these are all providing a 24/7, so that you need, at the comfort at your home, you are able to manage everything nowadays. At least myself, I do everything from home. I never step out. So this is how the AI is contributing. Okay, so these are the some trends. So that will give you a fair idea like where we are heading to. Okay. Now, so this is a little bit about AI. Now we'll talk about what is at scale. What do you generally mean by scale? Scale is nothing but an instrument to measure the growth, right? So when I try to develop something for a wider group, then I'm saying that it's like kind of I'm developing an application to support a wider group. Then it means it is, I'm trying to scale that application. That is what AI at scale generally means. Anything at scale. Okay, so anything that you try to do or apply for a larger group, larger users, then it means it's called scale. Now we look at some of these AI examples which you are all familiar, right? These are all examples of AI applications at the personal level, individual level, or household level, right? This is a very famous now, Fitbit trackers, right? Most of us are wearing nowadays to see how many steps I have walked or how many calories I have burned. So this is one of Amazon application. This one is I picked up from Amazon. This one is a vacuum cleaner, a silent vacuum cleaner. And you know, so much of demand during lockdown. If you look at the stats, right, so many people have purchased and sales have gone up increasingly because due to during lockdowns, I think many of us know no maids were allowed. So there was huge demand for this product. And this is a drone. I think you might have noticed many marriage functions, occasion. I have seen people started using drone cameras for capturing the marriage events or any events at the school. So that is the level of usage that AI has come into our daily life, right? And these are, if you look at this is a application of Google Maps. Wherever you go, you carry this, it can open and then navigate through easily to the various locations where you want to travel, right? Again, this is again developed to support millions of users, but one time one user, right? One user can use it. This one, I think you all know. Can somebody guess? Who is she? Sophia, yes. She has become very famous. I think 2016, right? Hanson Robotics have made this humanoid. She became very famous because she mimics human responses. She talks so well. She speaks so well. She gives interviews. I think she was the first humanoid who received Saudi America citizenship, if I'm not wrong. So that's a level of artificial intelligence has grown. And now we have, I think, 7 siblings of Sophia. And they plan to use these Sophia because in elderly care where you need a social interaction, where you need to have interviews, there all it is being used. Okay, so these are some AI applications that are used at individual levels. Now, when it comes to organizations, that is what is our subject now. These are some of the applications which are used for social problems in India. Okay, you might have heard about Niti Aayog. This is an organization, government organization. They are using this application in precision agriculture, in diagnosing diabetic retinopathy, building a language processing platform for multiple Indian languages. When it comes to agriculture, right, I myself have seen many applications developed by students, engineering students, where in the fields where they have to spray medicine, right, pesticides, the chatbots are employed within that field, and it senses the soil texture, and it will see the climatic condition, weather conditions at that point, and then will spray the required amount and the appropriate pesticide in that area. So those are the level of chatbots that were developed in agriculture, and those are developed by the students from Hyderabad here, engineering students. Okay. And coming to this, another example is Robert Bosch Center at IIT Madras is focusing in education, healthcare, agriculture. Similarly, Arunachal Pradesh government is using satellite-based systems to monitor status of infrastructure projects in untraversable regions, because Arunachal Pradesh, as you know, is a hilly area and many areas are not commutable. So for those areas, they have used this. On this note, I just want to take PM Modiji's one program, Swachh Bharat, right? When the program has begun, he wanted to survey or understand the status of construction of toilets at every village level. As he cannot travel, he has used some of the e-applications built on artificial intelligence, where he can lively view, understand the status of the completion of those toilets and understand the reality what's happening in those villages. And I was part of one of those projects where I have seen how it is being used by PM's office. And similarly, several police departments have partnered to tighten security. Similarly, railways are using this for handling catering and customer services. And now very famous, we all know about COVID. We all know that app, something they've asked us to download, right? Where it will tell you how many COVID effective people are around in our area when you move around. So those are some applications, and AI is also being used in vaccine trials. So the idea of giving these examples is to say that how well AI has influencing not only our daily lives, but across the society. That's why I'm sharing these examples. Okay. So this all talks about the scaling, right? I mean, starting from a point with the usage for an individual, we are extending its usage across the society in addressing the problems. Okay. Now, scalable AI. Another example that I would like to talk about is our whatever we do currently in our company. I mean, it's just a simple example because there's a lot more in that which you may not able to appreciate at this point of time. So I just want to say a small example where we use Broadreach. Our company is basically a brokerage services firm where we provide backend solutions for all the capital markets in UK. And every day we process millions of trades. You know what is a trade, right? When you, I think if you're, some of you are familiar, you go to a share market, you purchase shares by giving cash, delivering cash, and those shares are deposited in your demat account. But the actual exchange of shares is nothing but a document, right? So the exchange of document with money or with money with the document, all this can happen electronically at the back end, and we provide in a very smaller level. I'm explaining this example. So we provide solutions in processing and settlement of those transactions. So every day we receive multiple transactions of different trade types, and for various clients, various investment organizers, banks, basically. So what we do, we have developed some AI applications where it will determine what kind of failures for each trade. We have some set of mandatory criteria that has to be met in processing any particular trade. So we have developed an application, AI application, that will identify saying that this particular trade is missing these attributes, so this trade cannot be settled. So that is for only one client, one trade type. When we develop application to support so many millions of trades with the different trade types for different customers, that is called nothing but you're scaling your existing application. And in this scaling, you also try to automate some of these steps so that you will get a solution at a very faster speed. Then the moment the trade enters, immediately you can send an alert that this trade has these attributes missing, so this trade cannot be processed. So those are some of very applications that we have even in our organization where we use, and we also use AI in our investor communication services. At every level we use AI. Okay, so that is all the scalable about. And why we do this? To achieve a competitive advantage, because by scaling an application, you're improving your speed, reducing the errors, right? And that is what will give us a edge, a competitive edge over the other clients or other companies for us. So generally, this is what applications are scaled. Okay. Now, coming to what is scalable AI, it is a mixture of combination of several factors. One, data quality is. Second is data diversity. Third one is how robust is your application and how knowledgeable is the application. So to understand this, I'll just give you one example here. This I could pick up that happened very recently. This is an example of September 2nd. Okay, because of the COVID situation, and also the reason for picking up this example is it is related to online education system. Okay, so there is an online class going on in US. Actually, this is picked up for a US. This I think Edge UT is a online training provider service. They conduct classes online on behalf of a school for I think 6 to 10 students, 10th class students. And they have used AI for assessing the student submissions, right? So one of the student is pretty brilliant and he has given his very first test, which will be added to his final credits. Okay. So when he wrote the exam, out of 100, he secured 50. He was surprised because he was very confident that he did very well and he submitted all the assignments, and still he was wondering why I didn't get at least 80 to 90, why only 50. Then he was a little demotivated, but then he spoke to his mother, who is a techie person. Okay, she works in technology or something, I don't remember. So he spoke to her and then she said, maybe do well, maybe you might have missed some other points. So do well and let us make up in the next set of exams. Okay, So this went on, and again he submitted his next assessment. Again he scored less. Then his mother thought something is wrong. Then she tried to understand this gap. So she tried to compare his answers with whatever the system has provided the answers after the evaluation. When she has compared, his answers were logically very correct, but AI answers were completely different. So she was wondering what happened, why it has happened. Then she tried to understand that some AI is trying to assess this. So she tried to understand that logic, being a techie person. Then she identified that the AI algorithm, whatever is built in that assessing system, was trying to look for some keywords. Okay, even though he has written all the answers, as those keywords are missing, then that is why he's scoring less. Then in the third attempt, she tried to game the system. What she did is she suggested him to start using some keywords from the question and then write the answer. I mean, join two sentences using these keywords and then submit your assessment. So third time he did that and he secured very good marks. Okay, so this comes to her as a surprise. And I think you can read this article, very interesting article. So what happened in this case, though he was correct, because of the some inefficiency in the system, he was not getting the full marks. So that is why we need to have all these attributes to build a very robust, scalable AI system. And what are these attributes? And we'll try to relate this example with these attributes in the next slide. Okay, it is not, I'm not saying that all systems are like this, but whenever any system has these parameters, definitely it's going to be a very good system and useful one for us. Okay. And so we need to focus, whenever we're building a system, we need to focus all these attributes. That's a point I'm trying to make here. So data quality, to build any scalable AI, we need to have very good data quality, robust and accurate system, knowledge and diversity. Okay, data diversity I would like to cover in the next set of slides. But for now, we'll talk about quality, knowledge and robust and accuracy. There is a general misnomer that if you have good amount of data, you can build a very good system, which is not correct. It is not how much amount of data you have to build a system for analyzing, learning, building algorithms. It matters the quality of the system. If you have a data which have trillions of records and nothing useful, okay, it's all like, for example, you write a program to accept an integer, okay, and you give in a string as an input. What do you get an output? It will be a weird output that you will get, or you may get an error, right? Similarly, if you give if it is garbage in, you throw a garbage inside a system, you will get a garbage outside, right? So you have to always clean the data. And there are very many data cleaning techniques. You might have learned, or you might have learned how to clean the data. So those techniques, so you have to effectively clean the data. And if you train your models on poor quality data, your ending system will not function properly as expected. Okay, and it also impacts the testing and validation of AI performance. Okay, here again, I just want to pick up one recent example, which I read somewhere in UK. You have this Google location, not Google, some other application, which is used in UK. I think, I don't remember the name, but that will predict the traffic in a particular location when you travel. And it will give you an alert that there's huge traffic in this area, so you cannot travel. And seems that that application uses, in its logic, the number of mobiles concentrated in that particular area at that point of time, at that spot. If it is more, then it predicts there is a traffic. Otherwise, it says there is no traffic, absolutely, right? So what happened is, one day in a one lane, there is absolutely no traffic, but it was still sending out signals saying there is huge traffic in that particular area. When they looked at what exactly has happened, one guy was carrying 10 active mobiles in a bag, and he was standing in that area. So because in that area, based on the logic, if you have more mobiles, it means there is a huge traffic. So immediately it started sending incorrect signal based on that. So, which is not correct. The logic is not correct. The interpretation is not correct. They should have cleared it, right? clean the data. So that is why this also impacts your testing and validation of the performance. So that is why always data quality is very important when you want to scale your application, right? And second one is robust and accuracy. Your application, whenever we develop any application and scale it, we need to be able to apply for all set of users, all different companies, any context it should work, and it should work in any geographical locations. Then it's said to be a robust system. And robust system and accuracy both go hand in hand. One cannot be without other. The moment you say a very accurate system, it has to be robust. And if it is a robust, it has to be an accurate system. So this is another attribute or feature which we need when we want to scale AI application. Third one, this is more important, knowledge area. Now, just having a technical expertise, able to build data models, able to clean the data, build the algorithms is just not enough. You should also know the context of that application. Who are the end users that are going to use that system? What situations it will be used? So you should have all that knowledge, and you should also have domain expertise, right? For example, in the previous example, if you look at answering a particular, the same example of assessment, people should know what answers will be accurate to that particular question. So for that, they need not be an IT person. A teacher knowledge is enough to identify whether an answer submitted is correct or not, right? A domain teacher who is expert, a person who is expert in teaching for the class students should be able to provide you those inputs. So you should have those kind of knowledge, and those people should be involved in take inputs from those people while developing any application, AI application. So this requires domain expertise. Similarly, when you're building products for retail industry or FMCG, you should have product people in that team which is building that AI application. Otherwise, it will not be a full-fledged solution. Okay. And data diversity is something which we are going to talk in just few slides. Again, here requires diverse perspectives, what problems, whatever. We need to understand what kind of users are going to use that system and then build on that. Girls, are you with me? Hello?
We are all here.
Yeah, thank you. Hope it's clear, or you're able to follow?
Yes, ma'am, it's clear.
Okay, thank you. It's already 11, 10, 20 minutes more. Right, diversity factor. What do you mean by diversity? Any idea what diversity means? Okay. Now, diversity is, you often hear this word diversity. It includes all different kinds of sets of people, right? Different races, different genders, right? And different regions, different cultures, all this comes under diversity. Okay. Sorry. You will understand better when I take up the next example. Next slide. Now, you know, we have many artificial intelligence systems built to identify which will allow us to log in or open any application using facial recognition system, right? You just come in front of the system, it will scan your face or identify your face, and then we will be able to log in, right? So those are some of the artificial intelligence systems. So one study done by Boston Consulting Group, they have identified some issues with some of the systems built using that for that purpose. So they have identified that a facial analysis software showed 0.8 error% for light-skinned men, and see here 34.7% for dark-skinned women. So the application were not able to identify in case of dark women. And I think it assumed that men will be dark or something, I don't know. For light-skinned men, it showed error% of 0.8%. So when you're building that application, they didn't factor in this diversity. They didn't look at what kind of, the variety of users that could possibly use this particular system. So that is why we need to have diversity and inclusion. Okay, and this is becoming a prominent issue nowadays, because I think last year or before, Amazon had one system to interview the candidates, artificial AI system that will interview the candidates. Okay, no human intervention, system will interview the candidates, and it was built on some patterns, profiles built. And there, whenever a woman woman candidate used to come for interview, it used to disqualify. This really happened. You can look at the examples and Google it for it. Then later they understood why the recruitment rate for women is falling and why it is not, why it is more in case of men. Then they have identified that there's an issue with the system, and then they have rectified it. Okay, so there was a bias built in that system which was not qualifying the women and more men. Okay, so and why this is a reason? Because the application that has been built are built in a siloed condition. Siloed conditions in the sense built in pieces, bits and pieces here and there. They are not a wholesome solution that have been built by considering all geographicals, all culturals, right? And not taking any insights from different industries, disciplines, socials, classes, countries. Okay, and therefore the resulting system may reinforce inequality or bias. And again, this may not have been done very intentionally, or somebody wanted to do it purposefully. It is just a miss out to consider these factors when building the application. And a very, very recent example is with Moderna. You must have heard this name now, right? Moderna became very famous for its COVID vaccine trials. It is trying to build a COVID vaccine for COVID-19. And I think it is one ahead in the race in building this vaccine, and US is promising that we will release it very early, and there's a lot of competition going on. But recently, I think this happened on 4th September, they said we are trying to hold for a week the trials. There was an announcement made by the CEO, and the share price of that company has gone down drastically on that day. Everybody thought that it will achieve success and then it will be rolled out. The reason why they said is the data, the population that they're trying to do this vaccine trials did not consist minorities in that. Minorities in the sense women, some women, and then aged people, and some categories they have mentioned in the website, if you can go, who are really high risk of getting exposed to COVID. So those categories of people are not included in the trials. Therefore, they wanted to have done it again. So they want to correct the data, have good quality of data. That's why they kept the trials on hold. I think now this week or next week, they should resume it. Maybe you can just go back and check. So that is why diversity and inclusion matters. And now it is all organizations are realizing this factor. Okay. So whenever you develop any application, or when you in your future, whenever, please keep all these points in mind whenever you're developing it. Okay, next, this is about inclusion. Then coming to women, as again, diversity is important. Here, diversity is two aspects, or women are inherent to, we need data the data that is used for building the AI should be diverse. And the data engineers or who are AI engineers who are building that application should also have a representation of diverse factor, that is women representation is needed. Otherwise, the application that will be built is will be simply biased. Okay, so that is why they are saying women are key to scaling up AI applications. Okay, again, and they help in realizing the highest maturity levels of digital enterprises, because they will bring in different perspectives. Women will bring in different perspectives that will help us build a system that is which at the very highest maturity level. Maturity level is the sense it will be able to address all the solutions in a wholesome way. There won't be any chance of any bias. And that is why we need women. And in general, they are more resilient women. And don't think I'm a feminist, but these are the general characteristics which science has agreed, not me. Okay, I'm not promoting women or something, but this is something science has agreed. When they analyze the brain, human brain, these are some of the factors that have come out. They are more resilient, they have higher levels of engagement, ambition, and can bring in different perspective. That is why we need women representation both in data and both in the people who are contributing in the development of AI applications. And they help in removing this selection bias again. That's what I'm talking about. They would not restrict the data. They would try to get all the perspectives and then build the application during data modeling, making decisions, and also in testing the solutions. Okay. So why we need these teams? To reduce junk data and to remove the bias in the outcomes. Okay. And to improve the overall technology efficiency of that solution, whatever. Okay. So how many are really interested in this AI career, girls? Because yesterday I think you had a session on career opportunities. Purvi Lakhadi, me ma'am, yes ma'am. Vast area, who is this Akanksha? Good. Priya, Srinitya, Sahiti, Purvi, good. Zuha, good. Okay. Tajamul, okay. Tasneem Tajamul, good. Right. But when we look at the current situation, girls, this is what it talks about. World Economic Forum every year pulls out this report on various aspects actually. Now, this is something, they said there's a acronym for this, STEM. They called it as STEM, like fields particularly from science, technology, engineering, and maths. These are the areas, data science and AI, where we generally feel that women are not highly represented in these areas. And this is a study made by BCG, and they found that out of 55% are university graduates, out of that 35 go for this kind of STEM courses, okay, this gamut. And out of 35, only 25% will join the workforce, okay, they start working. And out of 25, only 15 or 22 will join into data science professionals. This is a trend that's been seen in the current situation. Okay. So I would like to see all the girls who said they are interested, okay, should be able to increase this percentage in the future. Okay. And there are various reasons why this happens. See, even in the corporates at the bottom level, around 10 years of experience, we have good representation, women representation. Middle management, we have again, okay, kind of representation. But when it comes to senior management, the representation goes down slowly eventually. Not many senior women leaders we can find. And there are various reasons for it. One, career options. Number two, the personal reasons, various priorities that they take at the priority decisions that they take at that point of time. And then interest, right? Eventually it fades out. So those are the various reasons that people start falling down as they move along the ladder. Okay. Especially, and this is especially in this area, data science area. And what corporates, universities, data science organizations are planning to, and they have already doing many things to improve the women workforce in data science area. And what are those? Let me just take a look at this. So there, see, generally AI is perceived as, to my experience, in my experience, I've seen that many people think AI is a male dominated area where women has nothing to do, but it is not the case. So for, as you have seen in your previous leads, when women representation is there, we will have a very robust, scalable AI systems in place, which will eliminate the bias in the system. That's why we need to have the representation of AI. and they are trying to implement some reskilling, upskilling initiatives for women. And this reskilling or upskilling is across the globe, girls. And even White House, you know, what's her name? Ivanka Trump. She's part of this STEM group. Okay, they have a group which they want to ensure that they have some percentage representation always of women in AI area. So that's what they are working on it. And if you look at not only women, everybody by 2022, at least 54% of employees needs this reskilling and upskilling. Okay. And these are the STEM STEM org is one organization you can log in and see where they provide exclusive courses. You can just log in and see for that. And creating special science and technology tracks for girls, realizing a skills-based future. Girls, this is keyword, skills-based future, because we have so many IT graduates coming out or other engineering graduates coming out, but lacking the skills. More than these degrees will help you to step into the firms, corporates, but the skills is what matters a lot when you start your corporate life. And these skills could be technical skills. These skills could be soft skills. They are very important for you to grow further in your career. Okay. And they are also looking at modifying the training so that the curriculum, so that it includes compulsorily AI. And also, it also should include the social sciences perspective. It's not just only technical aspect when you build an AI system. You should have the other understanding knowledge whenever you build this AI system, so that you can assess the efficiency of that particular algorithm when you build with this knowledge. Okay. Again, this is a whole thing, whatever points I have listed, it is in collaboration effort between organizations, educational institutes, and the data science organizations. And also many people, if you look, when I ask you, some of you, can anyone share what's happening in data science world, the trends? I will leave my slides, but do you have an idea what's happening in AI area? Hello? Yes, girls?
Girls, you can, if you're unable to speak, at least put it in the chat window.
Yeah, I'm looking at the chat window only. What do you think is happening in AI science? We'll leave this speaker's presentations. As an individual, as a student, what do you know? What's happening? Don't tell me Siri, Alexa, and all that, okay? That everybody knows. Anything else, you know what's happening? Where are we heading to? Cloud computing, okay? Robotic surgery is very good. Okay, in the interest of time, let's move on. Just 4 more minutes. Okay, fine, girls. I mean, I'm glad to see some responses, but again, no, if you want to make not only AI, anything as your career, and since you're all engineering graduates, not only IT, any other areas, please follow the trends. Please follow the for updates regularly to keep yourself updated. Okay, and that is where you will also build your skills. That's why I'm bringing at this point here. You have to continuously look at what skills are needed, because to be honest, when I started my career, I programmed in COBOL. I don't know whether you heard it or not, COBOL. And then I did programming in ProC, a programming language ProC, which is a kind of combination of SQL and C. From there, I moved on to Java, and from there to AI. So it's just like the technologies are changing tremendously. So you have to keep update and build your skills on those areas wherever you are interested to work and where there are opportunities. That is what I'm saying. So this is not only an action item for corporates, educational institutes, voluntarily you should also start looking at this to have a successful career. Okay. Okay. Now Also, another point here I would like to mention is so much of work is going on in AI, but it is not really made available to the people, to the forums, unless you specifically ask for it. And that is the reason many people, I mean, the trend shows that they are not interested in AI, or they find it is some black box, or they think that there's nothing much interest except for data scientist career, or there are other careers, right? You might have heard yesterday or day before. But that is not the case. There are so many women leaders that we have who are really doing a pioneer job in this area. So you should look at those areas, right, and get inspired. So that's the reason I'm sharing this screen quickly. There is an analytics forum across India, and they identify top women leaders in AI area who are doing extremely well. So these are for this year batch. And we also have another organization, I think you must have heard about Forbes, right? It lists globally every year who are the millionaires. I mean, in every category they list. They also have a list of top women performing well in AI. Since in the interest of time, I'm just skipping. I actually wanted to take you through each of their profiles to understand what they are doing quickly. One or two maybe for 11:30, right? Okay. But these are the, so a lot of work is going on, and so much is contribution is made by women in this area. That is what I wanted to tell you. And please go through this link later whenever you have time. Very interesting link, and you will get to know what's happening in this area, analytics area. Okay. And there are some suggestions, my personal suggestions, okay? Nothing written anywhere. Just improve your analyzing and coding skills, right? No matter if it's analytics or not, but still you have to improve your coding skills. And that confidence of writing good code comes when you participate in these hackathons, right? I think how many of you have participated, I don't know, but this will give immense confidence in we know there are ready-made applications which will write code for us, but still we need some human intervention in writing the code. So please do that. Don't give up. If first time it doesn't work, it's fine, but don't give up. Okay. Keep observing the trends, and you have to start enrolling yourself in some forums, related forums in your area of interest, so that you can keep updated with the information. And please focus on networking. Networking helps us a lot, girls. Okay. I mean, I actually, it takes one day to help how networking helps. At least in my case, it helped me a lot. So that's all I have. And the last slide. These are some technology skills I think I shared earlier also for the IT guys. Those who want to learn and grow in this area, these are some programming frameworks, front-end frameworks, all that are listed out here for 2020. The list may not hold good for next year. There could be some changes again, but fundamentals would still remain the same. Okay. And for high-tech economy, I think I already shared this with many students wherever I do. You should improve your complex problem solving skills. You should improve on your critical thinking capabilities. I mean, you should be able to come out a solution based on the facts, not only assumptions or something. Creativity is something that we need. People management, right? And last and but not the least, strong fundamentals are always needed. As I said, technology programming will come and go, but the underlying technology or the concepts will always still remain the same. As long as you're strong in your fundamentals, you will be able to easily learn the upcoming programs, because every year, not every year, every other day, the technology is changing, right? So that is more important. And these three things, if you remember, there was a lecture or a kind of small note shared by Google CEO Sundar Pichai to class of 2020 students pass out. I don't have that video, I don't know, but these are the 3 points that he raised, that they suggested the students should always have. You should always be open, you should always be hopeful, and you should be impatient. I mean, always eager on to learn something and then prove something. Okay. So that's all from my side, girls. Any questions, you can connect me offline. And I wish some of the people who said they want to pursue AI and all, I wish you list among these leaders once in some time in your life, right? I wish to see you here in this list, right? all the best, girls, and thanks again for this opportunity. Anytime you can connect me offline for any queries that you may have. And I have shared one small video link to Madam Anisha. It is a Tesla factory, car factory, production factory. Video that was shared on 31st August, very recent video. If you look at, you may wonder why this video, Tesla, it's a Chinese, Elon Musk, right? Why this video? The reason for sharing this video to show you this is the amount how AI is, the scalability of AI again, I would say that, okay. They produce 2 lakhs car at the end of every quarter. This production floor is completely manned by robots. One car is assigned 8 robots. The people that you look at, they are not human, they are all humanoids, okay. Just watch the video. And with that, I'll sign off. Thanks so much again, and all the best, girls.
Yeah, just a moment, ma'am.
Just a minute, ma'am.
Yeah. Just a 1 minute video. Sound, please. I can't hear.
Just a minute, ma'am.
It's a time-lapse video, but still the speed, look at the speed, how the cars are manufactured, identify the defects, correct it. It's amazing, actually. Okay, thank you.
If anybody would like to watch it again, we'll put the link in the chat window. A lot of disturbance in that. Anybody who would like to ask ma'am anything, or you wanted to talk to her?
They can connect me offline also, ma, if they want.
Yeah. Ma'am, thank you so much that you have spent your time with us. It's a Monday morning and you're all among us and having a schedule as already. So thanks a lot, ma'am. Yeah, if there is anything,
Some key takeaways, if you could find, I think I'd be successful. I mean, I feel I am at least done my job.
Yeah. Anybody, if you would like to talk to ma'am, please.
I can type.
You can just type in the chat window, or you can put me a private.
Blockchain, IoT, smart X-ray, scanner. Each of these are actually a different applications. Self-driven cars, NLP, healthcare chatbots. Okay. How do you suggest a final year to start off? Okay, there's a question from Zainab. How do you suggest a final year student to start off, right? It depends on which area you want to start off first. It's a very generic question that you have asked, right? First, identify your passion. That is my suggestion, girls. It's not not that somebody is asking you to do, and if you do it right, you may go ahead for some time, but you will not sustain it for a long time. First, identify what really excites you. Okay, that's my sincere advice to all of you. First, understand what really excites you, and then start building your career in that. If you think that is not going to happen very immediately, if it takes time, that's okay. But still, identify what is really interesting you. Don't just do something which for the sake of somebody else. That's my suggestion. And don't worry that if you are not experienced, you lose 1 year, still you didn't figure out what really matters to you, what interests you. That's still okay. If you are able to manage it later, then that 1 year or 6 months gap also should be okay. That's my experience with some. Because I see people coming for interviews, they say 2 years experience, they come enter. I mean, it's not that I don't want to comment, but you lack fundamentals, you don't have that enthusiasm. Then how will you grow your career? So first find out what is passionate for you. PPT, yes. Again, girls, somebody is asking what is more better in future for current final years, AI or data science? See, these are not two separate, they are all integrated. They are again together. AI or data science, they are all integrated together, ma'am. But the case wherein suggested to change depends on traffic comes on phone. Can you suggest something else that will go more? You have to look at the data in that particular location. You have to look at the data, what is really causing the traffic there. You just cannot build a model based on just identifying the traffic based on the phone network. Look at the data concentration in that particular area and build models on that. That's what my suggestion is. It is not always phone traffic. You can start how to start a career in AI for those who graduated 3 years ago. What area they are coming from? I need to those inputs. What was the previous, what they were doing with those 3 years? It depends. And if you really want to start a career in AI, and if you're not from IT, CSC background, okay. You need to do some specialization in it, if it is 3 years. You have a lot of specializations coming in, right? So you have to do one more specialization and then you can start in there. Maybe we need some more discussion on this. If you want, I can suggest we can connect offline. Apurva, right? Yeah, we can connect offline. Okay, girls?
Okay, ma'am. Thank you so much for being here, ma'am.
Thank you. Hope it was useful, right?
Yes, ma'am.
Yeah. Okay, thanks, girls. Thanks, Anisha, Professor Anisha.
So much, ma'am. Thank you. Thanks a lot.
Thank you. Bye.
For the invitation.
Yeah. Bye. Hello? Can I log out?
Yeah, ma'am.
Okay. Thank you.
Thank you, ma'am.
Nida, can you please share the break link?
20 minutes.
क्या
Hello, sir. Can you hear me?
Hello. Yeah, I can hear you.
Okay. So everyone, we have Mr. Debjot Paul today, who is a data scientist and machine learning professional. He had completed his master's in computer science from Indian Statistical Institute, Kolkata. He also worked as a software engineer, machine learning at Microsoft, and as a decision scientist at HSBC Financial Risk Management. Currently working with Amazon, working in the field of data science. He also participated in passionate research in computer vision, NLP, and adversarial machine learning. We're glad to have you here, sir.
Yeah, thank you. Thanks. Let me know if you can see my screen. I will present my screen.
Yes, sir, we can see your screen right now.
You can see my screen?
It's loading, sir.
Can you see my screen now?
It's still loading, sir. Oh, yes, sir, we can see your screen now.
Okay. Let me go to the... So, yeah, is my screen visible, right?
Yes, sir, it's visible.
Okay. So yeah. So today the topic that I will be talking about is computer vision. So the title what I would like to call is how this field is making the computers see the world and make sense of it. When I say make sense of it, so a computer, if you look at 60 years back, a computer at that point was just crunching numbers, and today also the computers are crunching numbers. The difference is that we have gone into this enormous field of machine learning and AI, which has kind of revolutionized the way the world works in last 20 years, and in last 10 years it has been really exciting. Today I'll be talking about one of the topic. It's a vast area, a lot of things happening. Also the topic I'll be working on, I'll be talking on, there's a lot of things happening there as well. And there's an enormous progress that has happened in last 10 years due to one technology I'll be talking about. So let's get started. Let's see a video. This is a video I have taken from Google. So I'll play it. So let's see. So this is a self-driving car. Let's see how it works.
Samuel, how are you? This is great. Go ahead, Steve. Auto driving. There we go. Away we go. Look, Mom, no hands. No hands anywhere. No hands, no feet. No hands, no feet. No nothing. I love it. So we're here at the stop sign. Yes. Cars using the radars and laser to check and make sure there's nothing coming in the way. I find myself. Old habits die hard, man. They don't die. Hey, anybody up for a taco? Yeah. What do you want to do today, Steve? I'm all for taco myself. All right. Well, go get a taco at the drive-thru. And we're turning into the parking lot. How? Go. Kind of creep along here. Does anybody have any money? I've got money. No, I've got my wallet right here. You roll down your window and order a burrito. Yeah, push that. And very well. How are you today? This is some of the best driving I've ever done. 95% of my vision is gone. I'm well past medium blind. You lose your timing in life. Everything takes you much longer. There are some places that you cannot go. There are some things that you really cannot do. Where this would change my life is to give me the independence and the flexibility to go the places I both want to go and need to go when I need to do those things. You guys get out. I've got places I have to go. You know, so, you know, it's been nice. You know, it's been nice.
Yeah, so this video was taken from Google. So hope this sets the motivation for the session. Yeah, so this was not possible 10 years back. People were working on it since 1990s, but we have recently made like huge progress here, and people are actually thinking about self-driving cars to be on road. I mean, they're already on road in US. And self-driving cars are supposed to take over, all Ubers and all these things in US in next 10 years, maybe. So yeah, so that's what we're looking at today. So what is a computer vision? Computer vision is, as I said, that the goal of computer vision is to make the computer see the world and to make sense of what is going around. So when you think of from the car, it is doing a lot of things. It is figuring out, when to cross a signal, when to stop, when to make a right turn, when to make a left turn. There's a lot of complex technology that is going on. It is making decision when to speed, at what speed it should go. It is reading signs, reading traffic signals, and it's like and it's a very difficult problem to solve. But I will show you some some technologies that actually help, that is actually works behind this. So we'll not go into details of how to implement it, but we'll go into how things work at the very basic level. So it has different names. Some people call it like image understanding, image analysis, machine vision. These are also part of computer vision. But computer vision today is both about image and videos. So let's look at. So in general, solving a vision problem is very, very hard because when we look at the world, there are so many objects. When you go to the road, there's so many objects, and we choose to focus. Like when you are crossing the road, you choose to focus only on the side of the road the traffic is coming. So you choose on specific part of it. So so we are we as human. We learned this as we grow, and we learn to focus on some objects, and the machine has to also learn, and it also have to filter an object of interest on which it needs to perform tasks. So this is how a digital image looks like. I mean, if you load an image in a computer, if you have ever used an image inside a computer, this is how it looks like. It's just a bunch of numbers. And the computer has to see this number. The computer cannot, look at the pixel. The computer at the very basic has, the access to this kind of numbers, and from this number it has to find patterns, and from those patterns it has to do all these complex tasks like self-driving. So to look at the timelines, how things has progressed. It started off in MIT, as a lot of things has. And in 1970s, 80s, people started questioning a lot of things, that how exactly vision, how do we perceive the world, and how we can make robot or a computer perceive the world. And then people figured out that vision is kind of based on the geometry of the objects we see. So it's geometry. So people started exploring geometric stuffs. In 2000, people again started moving back to the mathematical and statistical aspect. And finally, now I think last 10 years, people have explored neural networks for this, and there have been like huge neural networks, huge computational complex neural networks in action, which has made this kind of network possible, and we'll look at some of them. So what is computer vision like? So this is like computer vision like tries to get a sense of the 3D world around us, and sometimes the 4D, like in how it is changing with time. For example, if you look at a video, it's kind of we perceive the world as a video and not as an image. At every point of time, we are taking a sample of that video as an image and processing and taking action. Similarly, the computer has to do the same thing. So these are related fields to computer visions. So why should we study computer vision? Why should we be interested? Is because we right now have the capability to tackle this problem. In the past we didn't have. That's because like we now have more and more powerful computers. Computers which can process billions of computations in matters of seconds. We have cameras which have also developed to capture all of these things. So if you look at the self-driving car, there's a camera at the top which was spinning, and those cameras have become cheaper, and that has also made this possible. We have made huge improvements in algorithms to tackle this problem. So once you have the computers and you have the input, which is the image, we have made serious stride in terms of algorithms to understand image, to process image, and to make decision based on that. And with the help of all the three things, we have been able to improve the vision systems as well. So what are the applications? Applications are a lot of things. So 3D reconstruction. If you want to, so suppose in medical fields we have this. So if there's a 2D image, so an image is a 2D object. From this 2D object, can we make sense of how the 3D will look? That was one of the earlier questions of computer vision, and we are doing this in a lot of fields right now. So augmented reality, I think this will become another kind of a technology which is like already there with Pokemon Go and different kinds of games, where people are going more and more into the virtual world and trying to play games and be that there and have the experience of it. So we can make sense of images. So Google Image, for example, any kind of maps and all these things, it works based on this kind of technology which tries to connect images and form a bigger picture. So actually the camera phone in your like if you look at the panoramic camera in your mobiles, when you take a panoramic view, we usually rotate the camera around, take pictures, 3-4 pictures, and that gets stitched together. And how does it get stitched is basically dependent on computer vision. So yeah, we all have in those in our smartphone. So we looked at face detections. So people like right now all the attendance systems are moving towards this kind of technology. Like people just can log in to some place just by their face scan. Right now, people we have a face lock in our phone, which can just lock our phone based on which will open only if we are seeing at the camera. So those kind of technologies are also becoming very positive, and we have to think that these are not very easy technology. For example, tomorrow, like this has to stay there for different, like a person can be old and like it can be young. It doesn't matter. This technology has to work. And the mobile company is making one type of phone. It is not like a customized phone. So it is making a technology which applies to all. So it's a very complex technology, and like we have been able to achieve that. So animations, like any animated films, so the way we are having more and more realistic animated fields or special effects are because of computer vision. So you can see that this kind of technology is like we see that in movies like Harry Potter and all these things are basically applications of computer vision. So medical imaging, I think this is one of the areas which I find a lot of interest, and I'll show you one of the applications that I have done. in this field, and I'm still working on some of it. So which is like in really understanding medical images and helping the doctors to take decision based on that, which is like very helpful in some of the cases. Think about it, we'll processing like large sets of data and taking decision. It takes a lot of doctors, but if we can help them in achieving that by processing faster, by filtering the important cases out, people, and it can really help a country like India to progress, because we have so much pressures on our hospitals because of the population. So autonomous driving, I already shown a video. Robotics, I think next gen, we will be so much dependent on robotics, like drones and all these things will become so much popular, and it will be so much used in our daily life that this kind of something which we all look forward to. Surveillance is another technology, although there is a good and bad side of it. People are debating on the good and bad side of it, but we can make our surroundings safer with this kind of technology. To find if there is any violence happening or there is a mob or something like that, and alerting the authorities is something that we need to there are a lot of people are working on that as well. So so this picture summarize how the self-driving car basically is can basically drive so this is how it maps the entire street in terms of this. It segments it. The image segmentation is another kind of area where you can segment objects. So when the car is driving, it is kind of segmenting objects. It's segmenting humans, it's segmenting car. All the cars are in blue. All the humans are in kind of reddish, and footpath is in pink. So it knows that it should not drive on the footpath. It knows that there is a car in front of it. There's a human in front of it. We know that pedestrians are given the highest priority on roads, although that's not true in India, unfortunately. But in all of the Western countries, if you go, also in the countries like advanced countries like Japan, if you are on road, you are crossing a road, a car will definitely stop, and if you're crossing the road, no matter what is the signal is, they will stop. So that's what. So detecting pedestrians, detecting this, and getting the priority that whether it should speed or it not speed, all depends on this kind of basic technologies where you can see that road and everything is segmented. And another technology is the object detection. So now it is detecting the objects. What is the object? So there is a truck, there is a person on a bicycle, there's a car. So all these things are possible right now. I will show you one real life code which actually does it. So let's try. Yeah. So this is another very interesting application, and I'm very much looking forward to this. Is that computers become so powerful that they can generate image on their own. So if you look at the image below, the first row of images are actual person, and the second row are images which are generated by computers. They are not actual people existing on the earth. These are actually photos which the computer thought, and there is no difference. It can easily fool all of us that this is a real person. The second row is just fake humans. It is generated by the computers by looking at the images on the top. So it's that powerful right now. Okay? And I was talking about this medical imaging. So on the right hand side there are different kinds. So there is diabetes retinopathy, which is a data set which helps detecting diabetes. Retinopathy is one of the cases of diabetes which affects the eyes. So that is being detected using computer vision, and MRI images, different kind of lung diseases, CT scans can also be scanned, and we can look for anomalies there, and we can detect those anomalies, and we can alert the doctors. We can help the doctor figuring out the anomalies and take decision based on that. Now we can do diagnosis based on that. So what are the mathematical tools that are important here? These are the mathematical tools that are kind of used in current computer vision. Moving ahead, so I will talk about one of the core technologies of this computer vision is called neural networks. I have kept it as basic as possible. So we will look at a neural network from logic gate perspective. I hope everybody of you understand what logic gate is. Since you are from engineering background, you must have seen some of them at some point in your life. So this is kind of a neuron that that is kind of in our brains. How does a neuron looks like? So it has a nucleus, it has a dendrite, and it has an axon. So what happens that the dendrite receive information from other neurons, and then there's a processing that happens. There's an electrical signal that gets passed and processed, and it passes on to the next neuron via the axon. And our normal neural networks or computational neural networks works in the similar way. So they are not different. We as a humans are built about billions and billions of neurons, and that's what we can think so complex. We can perform so complex tasks because of these neurons. So we are about we have around 100 billion neurons. If you think about it, there's a huge number of neurons. So a neuron can connect with as many as 1 lakh neurons. So you can think about the network complexity here. There's 100 billion neurons in our system with 1 lakh connection per neuron, which is huge, right? I mean, if you think about the matrix, let's say 100 billion cross 1 lakh. So it's in a graph adjacency matrix. That's a complexity that we have, and the current neural networks are nowhere near this. Okay, so what does this biological neural networks do? They pass electrochemical signals, and the synapses release chemical transmitter, and this can help in passing the signal, in processing the signal. So all of our activities are guided by these neurons. So yeah, synapses. So synapses learn whether to pass or not pass these electrical signals, and that's how we perform a task. So all of our complex tasks can be ultimately summed up to some synapse or some neuron getting activated or not. Okay, so yeah, so first neural networks was developed in 1943, so we can see how the principle works. So biological computational neural networks works like this. So this is on the left hand side are other previous neurons, and then the neuron pass the information through a dendrite, and it receives through the neuron Y, which processes it, and then again depending on the activation, it passes on the activation to the next neurons. So as you can see that the output of Y is 1 if the Y get activated, otherwise it is 0. So basically, depending on the input, if the input is large enough, then Y will get activated, or Y will have some threshold potential. If this activation goes beyond that potential, it will get activated and it will pass the information to the next neuron. So depending on this, we can also mimic the biological neural network. Moving on, we will try to look at this neuron Y has a threshold, and suppose that some of these suppose these weights. So each of these neuron on the X neurons, X1, X2, and X3, there are 3 different neurons, and each are connected with a weights. So the weights, you can see that 2, 2, and -1. These are the weights. So the output of X1 gets multiplied with 2, and it gets passed to Y. So what Y does is take a weighted sum of all the inputs. So if all the inputs were 1, so the sum would be 2 plus 2 plus -1, that means 3. So 3 is definitely greater than 0. So Y will get activated, and that's why it will pass the information to the next neuron, or it will take some decision based on this. Okay. So let's look at an AND gate. So as you can see, the AND gate, the logic table is given here, and how we can perform the AND gate here. So we will pass, so we will not tell what is the weight of this. So you can see the weight of this is 1. So what happens is that if any of the input is 0, then or both of them are 0, then it will always receive a value. Y will always receive a value of 1 or less. And if you keep the threshold at 2, then it will only get activated when both the neurons are on, and then only it will be 2, and then it will output 1. So we can mimic a simple AND gate by this. So OR gate, we can also do the same thing, like we can keep a threshold of 2, and if both the neurons or any of the neurons are previous neurons or X neurons are 1, then only Y will get 1. So that's kind of very obvious. So this is kind of like AND NOT function. So as you can see that from the logic table, that it gets 1 when like 1. So x1 is 1 and x2 is 0. So at that point only it gets 1. So you can put a potential like 2n minus 1, and if you give a threshold of 1, so when x2 is only 0, then only x1 will be, and x1 is 1, then only y will be 2. For all other cases, y will be less than 2, and that's why the output of y will be 0. So these like very simple things, like the normal neural networks are not that simple. So ZOR we can also implement in the same way. If you look to the diagram, you will figure out how ZOR is implemented. Let me like this is how we perform as well. So if we if we touch something hot, then our neurons pass the information that is hot, and then this information goes all the up to the brain, and the brain process that what should it do, should it remove the hand or should it do something else. So suppose like you are actually taking a hot cup and giving it to someone. Although it is hot, your brain kinds of gives the instruction that keep moving the cup. It will not be there for very long, so you will soon detach the cup from your hand. But if it is something like you have touched some some utensil which is hot, then your brain will instruct that immediately remove the hand, and your motor neurons will then get activated, and it will help your hand to move. So this kind of similar way our computational neurons also work. So this was a simple example that I told, but in reality, neural networks are way complex. So this is a complex neural networks you can see on the screen. This has like so the input, there is a lot of input and they're interconnected. So you can look at the connection complexity of this neural network. It's way higher. So this is kind of a very complex neural networks, like it's called deep neural networks. And this kind of neural networks actually paved the way to do all these complex tasks. So right now, if we look at all the neural networks behind those image segmentation that I described, behind the object detection thing, they're really complex. And I will talk about one neural network which actually solve those kind of, which are the basic neural network behind those. There are different types of neural networks, different types of connection. These neural networks are the most simplest neural networks that I have shown. So this is just to give you motivation, but in reality, the neural networks right now is very complex, and we will study one basic version of it. So what happens in these neural networks? The yellow, so all these round, circles that you are seeing are basically neurons. So what happens is like if these neurons are kind of like what happens to this neuron. So the yellow neurons are basically input or output neurons, and the blue neurons are called hidden neurons. So the input neurons get input, like for example, if you are inputting an image, you will input the raw pixels in these x1, x2, and x3, and up to x6. For example, if you are inputting some other feature, like for example, the getting feature, so then you have to input all those x here, and the y are the basically the output that is expected. So suppose like I want to classify image, I want to find whether it's an image of a dog or a cat. So what I will do, I will take given any image, I will break them into pixels. So images are made up of pixels. If I go back, if you remember that matrix which I showed, which is an image, I told you that images are nothing but matrix of numbers. Then like each of the numbers are basically pixels. So you'll input a pixel to each of this neuron, and then the neuron does a lot of computation, and then it will either output that a cat or a dog. So if you input an image of a cat, so first you will give some training data on which the images of cat and dogs will be marked as which is cat and which is dog. and then you will pass that neuron, the pixels to this, and you will train the neural network so that it learns that which are the images of the cat and which are the images of the dogs. And this hidden neural network will actually help to learn that. This will try to figure out that which part of the image are basically looks like dog and which part of the image looks like cat, and it will try to learn that which are the so given a cat image, which are the features that it should look for or to check. So for example, when we look at a cat picture, we look at the size, we look at the facial structure, we look at different kinds of other features. The cat is more has more similarity with tiger, and dog is more like a wolf or something. So those kind of similarity we try to map, and then we try to find out whether it's a cat or dog. Similarly, this neural network will try to find out those pictures. So depending on those pixels, it will see that which pixels are there to figure out whether it's a cat or dog. So any questions so far? I'll pause for 2-3 minutes. So if there are any question, people can come on mic and ask, and then we can proceed. Okay, so yeah, no questions. Can I move forward? Hello. Can I move forward, Anisha?
Hello.
Yeah.
Sir, you can go ahead, sir.
Okay. So let's move ahead. So let's look at how we as human perceive our object. So we have our retina and we have our lens. So through the lens we visualize the world, and we have our neurons inside our brains. Which so so basically what happens that when a object comes in our visual field, so you can look at the left visual field and right visual field. So all this makes our total visual field. Whenever object comes there, it gets projected into the eye, and what happens is that this gets reflected on our retina, and the retina then does a operation which is called convolution operation. There's a series of convolution operation. So the retina is like a feature detector. So what the retina does is that it takes those pixels and it tries to see that is there any object that kinds of is there. So how do we actually figure this out? We figure this out during our learning process as babies. The baby starts to, so it has been found by experiments that the baby starts detecting color at 3 or 4 months old, and then they start detecting object boundaries. So a baby cannot identify person just by looking at them. So at the very early stage, but as the baby grows, it starts identifying people by looking at their face, because they start to look at those features, that whichever the feature facial features are there, and they start to learn that. So that's how we learn. So we look at these pixels and we can make sense of how these pixels actually work. So similarly, a computer does the same thing. So I will show you a neural network which basically, yeah.
Hello. Hello.
Yeah.
Sir, if you don't mind, could you please check with your audio connectivity, sir? Because there's a lot of break in your voice, actually.
Okay, let me check.
Yeah, please.
Can you hear me better? Am I audible better?
Yeah, it's clear, sir.
Okay. So maybe there's an echo that is happening. Is there any question? I will think that. Let me project that. Yeah. So So the computers has also needs to look at the image in that respect and learn. So let's look at a very simple example. So this is a simple example. So what is on the left hand side? The left hand side there is a there is a image of a handwritten digit. People started with this simple kind of task. So a handwritten digit is very different from a normal digit, because it has a lot of different people write the 2 in different manner. So it's a complex task than recognizing normal digits or computer or typed digits. So this is one of the complex tasks that people started off with. So what we actually look at, so when we look at these handwritten digits, what we actually look at, can anybody tell me, like from their experience, like if you are looking at this handwritten digit, how are you knowing that this is 2 and this is not any other digit, or this is not 3, which is similarly looking, by the way? So how can someone figure that out? Can anybody answer that question? So how can we look at our image and we can figure out like a handwritten digit that it is 2? So anybody? This doesn't require any neural network idea. It just so let's see if somebody can answer it. It is with the pixel available, of course, but what is kind of a mode? So look at the image of 2. What actually you are? How do you know that it is 2? What features are you looking at to figure out? So when you are figuring out it is 2, what is actually you looking for? No, I know we are trained and we can recognize it, but how we actually trained is what I'm asking. How we actually, so when you are studying this, at your very, at the childhood, when people say that this is 2, this is 3, how do you actually, figure that out? We already know it because we have learned it. There was a point when you couldn't recognize it. There was a point you could recognize it. So there has been a training in the process which helped you recognize it, right? So what was that process is I'm asking, right? So I will answer that. I mean, let us just project it back. So look at the stroke, right? The 2 has a curve in the side, which is also 3 has, but 3 has 2 curve actually. 3 has, if you look at 3, it has 2 curve. 2 has only 1 curve, and also it has another, so it is very similar to the bottom part of 2 is very similar to 6, right? So it has another opposite tangent curve, and so we as a child we used to figure out. So this was an automatic process for us because we are so evolved machine. So we can actually figure this out without even thinking so much. But a computer has to look at it and figure it out. So what a computer is doing, it is doing a series of feature extraction. So what it is doing, given this feature, it is so all these blue blue boxes or blue rectangles that you're seeing, these are called convolution operator. What is a convolution operator? Convolution operator is basically putting a lens over the top of it and seeing part of the image. So suppose so it is like inspecting a image by pixel by pixel. So but taking groups of pixels. So a single pixel doesn't mean anything to us, but only a group of pixel does. So we will look at that. Like for example, when we are looking at the stroke of 2, there is a group of pixel there. So what this convolution operation basically does, or this convolution layer we call it, basically does our eyes also does this convolution operation. So what does it do? So it takes a group of pixel and it focuses on those pixels, and then it tries to extract some information out of it. And as we go more depth of our brain, what it will do, that it will try to stitch those together, and this is how the vision occurs. So the image that is on our retina, it leads to different neurons getting activated of a convolution neuron, and this convolution neuron stitch the image together, and then only we can see that it is 2. So we have make a mapping in our brain that if there is a curve like this, then it is 2. And that's why whenever we are seeing this, it's immediately coming to our brain, this is 2. So similarly, the computer, what it does, it takes the image and it takes groups of pixels. It takes groups of pixels, and on those groups of pixels, it tries to learn that what is this groups of pixels has to tell me. And how does it learn it? Because I have already told that computer that this is image is 2. Based on the training data, in the training data, it has the mapping that this is the image of 2, and here is the label. So for any given image, there is a label, and it knows that this is 2. So when based on this, it tries to figure out that, okay, if this is 2, then what should I be looking for to figure this out at 2? So it makes all the difference with 3 with other similar things, and it tries to come up with that. And the only way to do that is by looking at group of pixel and trying to see that what those group of pixel is different for 3. So if you look at different groups of pixel between 2 and 3, there will be difference, and all those differences helping it to understand what is the difference between 2 and 3. So in this way, the computer learns. So this is the architecture of the neural networks, which gives the best performance, almost the best performance in this handwritten digit recognition. There are more advanced neural networks in this area, and almost all of the application that we saw is using this kind of architecture somewhere in the network. So there are a lot of other technologies involved. There are a lot of other algorithms, a lot of other framework involved. But at the core, at the very core of this technology is basically a convolution neural network sitting. A convolution neural network has a series of convolution operator. What is a convolution operator? Convolution operator is looking at a group of pixels and then making sense of those pixels. So it does the series of convolution operator, and then it takes the final output of it, and then it tries to classify using a normal neural network. So this is a convolution neural network. So let's see. So this was the normal neural network that we were talking about, and so it is called a fully connected model because every neuron is connected to every other neuron. But in a convolutional neural network, only a group of pixels gets connected to the next group of pixels. So that's how it occurs. So as I was saying, that whenever we make sense of an image, we look at a group of pixels. So for example, when I'm deciding what bird it is, we look at the beak of the bird, we look at the eye of the bird, we look at the feathers, we look at the colors. So all these things are groups of pixels. So we have to look at groups of pixels. For example, the feature here is the beak. Okay, so so what it does, so this it extracts this beak, and then it passes through a decision making step, which we saw that in the AND or logic step. So and it decide it's a beak. So it's and in this way, using the beak and all these things, it tries to understand what kind of bird it is. So okay, so this is the upper left beak detector. So this is like middle left beak detector, and this it's learning the beak kind of filter or convolution that is basically learning that the input has the beak, and based on this beak, it can figure out what kind of bird is there. So suppose this is an image, this is a 6x6 image. As I said that images are nothing but matrix of numbers. So when you apply a filter, so what happens is that it transforms this image to a smaller size image. And how it does it is that it groups pixels. So it looks at some of the pixel here, and then it kinds of group them and output a number for each of the pixel. And that's how it makes sense of the so this is how it is detecting the beak, because it is taking the whole image and then it's focusing on different parts of the image, and on the area where the beak is there, it is focusing more. And how does it learn to focus more is by knowing which part of is the beak, and by knowing the bird. So when it learns different images of the bird, it looks at different images of the bird and see that what is the difference between this image. The difference between these images are the beak or the feathers or the size of the bird. And the way to do it is that by taking these groups of pixels. Okay, so this is a convolution operator, and so this is how it occurs. So you have a filter. A filter is like nothing but a weighted product. So it has another matrix. So and this matrix is the neural network has to figure out that what this matrix will be. We have some mathematical steps to find what this right hand side matrix will be. The left hand side image matrix is given to you. The right hand side we figure out by using some optimization steps and some learning steps. And basically like this filter or the right hand side filter is then taken and it is taken dot product. We do a cosine product or dot product on this, and then we get an output. So for each of the 3x3 pixel, we'll get an output, and that's why we'll get ultimately get a 3x3 matrix out of it. And again, that 3x3 matrix will be taken out in the by the next layer, and similar operation will be followed. Okay, and this way we will learn that that what is happening inside. So as you can see that we will generate another matrix from it. This is a 4x4 matrix unless the left hand side 6x6 matrix. And in the next layer, we will apply a different filter to find it. So initially all the filters are randomly generated, but as the computer tries to learn, it will learn what filters to apply on its own. And this is the filter. When the computer figure out that what filter it will be, it will be able to generate the right results for the data set. For the handy digit recognition, it will tell you that what is the handy digit. Okay, so let's go ahead. So in this way, it will try to generate all the different pixels. So these are the feature map, and on this feature map, the final output will be processed. So for example, for RGB, we have 3 channel of image: red, green, and blue. Okay, so for this will be transform to 3 different channels on this channel. So in this image, there was only 1 channel. In normal real life images, there are actually different channels, 3 different channels because of RGB. And on this channel, the conversion operation occurs on 3 different channels separately. And then so there will be 3 different filters, and then finally the output is processed. So from the image, we do the convolution and finally get the feature. And then using this feature, we finally use a fully connected network, which was which we saw in the first at the first variation of the neural network, to finally found or to classify an object or to take decision. Okay. So this is how it is offering. So suppose the input image is there and the filter is already given to you. Then this is how the finally the network is taking and grouping all the pixel, and finally it is outputting 3 and different values. Okay, so this is the whole convolution neural network. It is taking the image of a cat, then it is doing convolution. Max pooling operation is basically sampling. So there is a lot of sampling also involved. Like you take the pixel and only take half of the pixel at every time. There's a sampling involved. And then you finally generate all the neural network that is there. So so I will move ahead because this is a slightly so a max pooling is an operation of sampling. So it works as a normal electrical or electronic sampling. It's nothing different. Any kind of sampling is basically you take a bunch of numbers and then you only select a portion of those numbers. So that is any kind of sampling. So it also does the sampling because the images can be so large. You can't process all the image, all the pixel. So you have to throw away some pixel and only select the important pixels. And the way to do it is just by doing some sort of sampling. So so this is like if you take an image like a bird and you do sampling, what it will do is throw away a lot of surrounding pixel, and it will give rise to a smaller pixel. However, it will not it will not kind of it will just diminish the size of the image. It will not do anything to information content. Information content will remain still almost the same. It will not change that much. Okay. So yeah. So let's. So this is how so every convolution and pooling layer will generate a new image. Although those images we can't make sense of, but moving ahead, like those images will be used by next and next neural network. So every every step of this neural network breaks the image into more and more features, and those images have a lot of feature content. So basically, it every step tries to remove the noise and tries to focus on the feature that is important for the task, and those features are carried forward. Okay, so. All these things are available in a Google library or TensorFlow library that is called Keras. It can be also used like PyTorch or some kind of library you can use in Python. If you know Python, then you can directly use this kind of. I will show one code example, although I will not go through the code, just show you the output that how it is working. And you guys, if you know Python, then you guys can directly, code, like learn this very fast. It is very easy to learn how to apply these neural networks. And you learn how to apply this, and you can generate this kind of system. You can generate your own object classifier. You can generate your own face detector based on this. There are a lot of resources on the internet that can help you. So if you have not studied Python, please do. Or if you know MATLAB also, MATLAB is another language which has the support of neural networks where you can go. But although like the neural network community or all the machine learning community are favoring Python more than MATLAB. Okay, so because it is open source and there are a lot of free technologies there. Okay, so so I will skip these parts because these are really detailed and probably we will not be able to make a lot of sense of it. I will tell you one story. So this is a game called AlphaGo. Probably some of you might have heard of it. So this is an immensely complex game, and this is like similar to Chinese checker. I don't know how to play it, but from the point of interest of machine learning, how it came was in the last year. I think in last year, in 2017 actually. So what happens, like a computer can play this game. How can it play this game? It can look at the board and it can take the image, and the image can be passed to a neural network, and the neural network can know how many blacks and whites are there, and it can find the next move. And so what we have achieved doing this, I mean, okay, so using CNN, what we have achieved. So the neural network architecture that was used. So AlphaGo is again a Google neural network. So it uses a neural network. It uses 23x23 image, and then he's used different parameters of convolution in neural network. So then what happened by doing this? If you Google this, you will find that. So what we have achieved by doing this? We have actually achieved. We have beaten the best human being in AlphaGo in last 2 years. So in last 2 years, it has beaten the best AlphaGo player in the world. The computer has beaten that person in this game. So just by this, looking at the picture, the computer is being able to figure out what the next move should be. So it has taken all the videos of a human playing this game, and from those, it has looking at the image, it has learned that what should be the next move, and based on that, it has figured that out, and then it has actually learned how to do it. And now, given a state of the board, so at every point when it's taking a picture, it's taking a state of the board, and it is deciding a next move. So it is giving that move, and then the opponent is giving the move. Then it is again taking a picture, and then again it is doing. So there's a different branch of machine learning algorithm called reinforcement learning, which studies this, which is like game playing, which is also in robotics, where a robot how to navigate. Because a robot doesn't know the world, it figures out the world. So if you leave a drone, it doesn't have any idea what is there. So from the world, it figures out what is there. So it's kind of those kind of architecture, and it's really popular. So we actually have this networks are so powerful that they are beating the and I think in last week the best the best military pilot got so AI driven fighter jet beat a human in US. I think they have tested that, and in a simulation they have found that it is way better. So in next year, all the military technology and everything will start moving towards robotics, and people will use more and more robots to wage war and all these things, or for security purpose. So we are actually moving all those sci-fi era where we will be using robotics to achieve all these things. So let's see a lot of more interesting examples. So speech recognition, we can use CNN for speech recognition. So we can take the spectrogram of the speech, and we can understand what a person is talking about. Okay, so we can do text and all these things. So with this, let's look at some of the computer vision algorithm at life. I will give 2 such example, and then walk you through one problem that I solved using this. So this is this is called a very advanced architecture called masked RNN. I used a Google Collaboratory. In Google Collaboratory, you can basically run all this code, and it is free of cost. You can just go log in with a Google account, and you can learn. You have GPU, which helps learn this model faster. Run this code faster. So what is happening, like here there is an image that is taken, and I have already taken this library from some of the already available library in the internet. This code is not, by the way, not mine. I have taken it from an open source GitHub page, which was this is an image that is inputted to the neural network, and then the name of the neural network is called mask RNN. What happens? Sorry. Yeah, so what happens is that when you look at this image, what happens that the neural network, the computer actually figure out that which are the objects, and actually what it can do, it can actually, if you look at this object, it will, so if you look at this green and all these things, it can figure out that what is happening. So it is this many lines of code that is just doing it. Okay, so it's so simple. Like if you look at it, so it has given all the name of the features here and what the neural network. So I am getting the image from the internet, and then there's already trained model which was trained, and that has been loaded, and using that this model is making the decision, and it's so clean. You can see that it is actually figuring out all the images, all the objects in the images. So this is object detection. And let's look at another example where I have trained actually this is also a code that I have taken from the internet. So what we can see is that I have trained a neural network, and this one image, the actual caption of this. So this is for caption generator. So what happens in caption generator? You give an image. For example, it can be used in live cricket commentary, where a computer is looking at a cricket match and it is generating live commentary, and that can happen. That is not very far. We will be going into all those spaces very soon. It is looking at a picture, and what is doing? The real caption is given. Real caption is a crowd of people walking down the road holding signs. So if you look at this image, I don't know how much it is visible, but this image is basically a lot of crowd, and they're holding placards in their hand. And what is a caption that is generated by the computer? The created caption is a group of people, all protest march, and people. So it is like, see, look at the power of it. It is generating almost like a similar caption, or almost similar to the caption that is actual, that is the actual caption. So these are if you look at what is happening inside it, it is actually so this is one surfing image, and if I input the image, it gives me the caption: a man riding a wave or surfing. Okay, so look at the how accurate it is. And it is so when we looked at inside the neural network, what is happening, what is the portion of the image it is focusing, you look at it, it is focusing on the waves. It is focused, so this is giving the wave, this is giving the surfing, and this is giving riding, and this is giving man. So you can look at this, that when it's saying that's man, so it is actually looking at the man, and it is directing it's a man, and then it is looking at the wave and it's saying it's a wave. So riding is some action that is happening. So it's actually learning all these things. So this image basically proves that it is learning that. So this is kind of the power that we have. And with the 3 minutes that I have, I will walk you through one very relevant thing that is there. So you will find this application also throughout the internet. You will have tried it. The new thing that I have tried is COVID testing. So a lot of people actually looked at lung X-rays and trying to figure out whether that person has COVID or not. So initially, when there's a person who actually there's a research group which actually released this data set of around 115-200 COVID related X-rays which are marked whether that lungs X-ray has a COVID or not. Usually since the data was very small, all the codes that are in the internet, they kind of breaks. It doesn't work in a lot, because they kind of say that it's a COVID or non-COVID, but if you test a bit, you will find that they breaks. So what I did is that so these are very so let me just project it. We know that COVID testing is a very important thing, and around towards the early, people were actually actually China and a lot of companies actually invested in finding COVID using X-rays. So because X-ray machine, unlike COVID machine is very costly. Like these PCR machines are very costly. So what X-ray machines are available in almost all diagnostic centers. So what they are saying is that if there is a way so that people can be scanned or X-rayed of their lungs, and we can have a way to tell whether the person has COVID or not. Even that is has very bad results. It doesn't matter, because we can actually filter out a lot of people, because for a country like India, it is really difficult to test everybody. So what we can do is that we can filter, or we can take we can actually filter out a lot of good cases, like which are normal cases, and only focus on the age or boundary age, or like more advanced cases. So that was what people were saying, and neural networks or this kind of technology can actually help. So what is the power of this neural network? That as I said, that this neural networks actually can learn from another neural network. So what can happen is, suppose that I have already a data set which I have trained for some other task. Suppose like I have a data set which I have trained for cat versus dog. So actually I can take whatever learnings that is from that neural net, because those neural networks are actually numbers. I can use those numbers, and I can now use that in my network to learn a different task. Like I can do dog versus tiger in that, and I will achieve kind of similar better results, because the neural. So think about this. So if you already know that what is the difference between cat and dog, you can always figure out what is the difference between tiger and dog very easily than a person who doesn't know. So similarly, the neural networks can also do that. So I actually found a data set which actually is a lung disease related data set. That is a pneumonia related data set. So I actually found that this neural related data, Stanford has a model which was trained on this on this neural related data set, and that model was doing very good on that data set. So I actually took that model and then I retrained on the COVID related cases. So if you look at the left hand side is COVID positive and the right hand is COVID negative. On the left hand side, you can see a lot of blurred region which are basically showing the lung opacity, which can happen due to COVID, because of there's a deposition of fluids inside the lung. But the right hand side you can just figure by naked eye what will the difference. So what I did is like there is already a model that people have trained. So they have just trained it using the COVID and taking some example from pneumonia. So what from the pneumonia data set, I actually used the model that was already there for pneumonia data set. So this model already had the idea on like 100,000 images of what does a lung X-ray looks like and what is a disease lung X-ray looks like. So what my hypothesis was that if there's a disease due to pneumonia, since influenza, pneumonia, and all these things are very related, and people are saying that it is very difficult to find out what is the difference between COVID and this kind of symptoms. So I had this hunch that maybe the lung images also would look similar, but we have to only segregate from the disease lung image, so it's a normal lung image. So I took that model and then I retrained on the COVID images. So this is a model that I use. This is a ChexNet. So it is like already trained on all the pneumonia data set. So I already took this model and I trained, and this is kind of what it is like. This is called transfer learning. So I took ChexNet and I transfer learn. Transfer learning is whatever I was telling, that if you already know the difference between dog and cat, you can be trained very easily to find the difference between dog and tiger. So the similar for neural network. So here I took a neural network which already knew the difference between normal and a pneumonia lung X-ray, and I retrained it for a new normal versus a COVID lung X-ray image. And as you can see that the second image is actually a COVID image, and it is actually, so in the first image it is not finding any anomaly. The second image is finding a lot of anomaly, and that is shown by the heat map. So and actually I got an accuracy of 91%, and so a more advanced score like F1 score of 91% is actually 91% of the time it is saying the COVID cases accurately. So think about the application. Even we will have like 10% like people, if you miss, you can always check those 10% to be more sure using some PCR technique. And the remaining percent who are actually scored high can be actually given treatment and actually found, we can actually make very progress. Actually, I reached out to a lot of, institution with this. I didn't find very good response, but I don't know, because people are not maybe investing in this a lot. So yeah, I mean, so this is like the overall, what is the neural network generates. As you can see that it is for some of the images, the COVID cases, it is kind of coming up with the different kinds of, so it is detecting that what is going on in that lung, what is the fluid that is deposited. And from these images, we can see that. So if you look at some of the images, it is actually detecting the blood area very prominently. So, so just to move ahead. So yeah, so deep learning is can be used for this kind of technologies, but we are still very far away from developing very good models, because all these models are at risk of learning biases or learning wrong things. So there was an example. So this is not all magic. That is what I want to end my session with. That all these things which we are actually making an enormous project, progress. But at the same time, there's a pitfalls. For example, there was since machine doesn't know. I mean, we are giving this training data to the machine. The machine can learn wrongly. So there was an example where a machine was trained to differentiate between husky and wolves. So huskies are this snow kind of dogs, found in really cold climate, and wolves are like normal, wild wolves. So they look kind of similar. So a neural network was trained to do that. So actually, on the training data, the neural networks performed very well, but on the test data, it was not performing well. So when the reason was found out, the neural network was actually focusing on the eyes as a feature for husky, since husky occurs in a lot of Siberian region. So what it was thinking that if there is a ice, then it is husky, otherwise it's wolf. So there can be this kind of pitfalls. There was one example where a girl, because it has golden hair, was confused with a golden retriever, which has also like kind of similar fur. So similar color fur. So those kind of pitfalls are there. But anyway, we are making progress, and we will soon be able to develop very advanced models which are kind of less prone to this kind of error. So the conclusion being that there's enormous development in computer vision technology, and it is still going on. Every day a new model comes, every day new technology comes, and this all driven by the deep learning technology and the advancement in the power. So we have right now GPUs or graphics processing units or TPUs and the tensor processing units. So all these things are actually helping us move all this cloud computing. This we can very much store like GBs or TBs of data or petabytes of data are making all this possible. So yeah, that's where I would like to stop. I will open the forum for questions. Yeah, so please go ahead, and I'll be happy to answer some questions.
Girls, if there are any questions, you can please put them in the chat window. So there is one question in the chat window.
There is a lot of software available, so yeah, there is already a lot of software available because people are already working on this kind of special effects. They are really very costly because it takes a lot of computation power to generate this kind of software. But yeah, they're already available.
Anybody else? There's another one, sir.
Yeah, so you should look at Python, and Python is the code to all this, whatever I showed, all the code, all the coding has been done. Python as a base language, and then there are libraries in Python like TensorFlow, Keras. All these are libraries in Python, or PyTorch, which are actually very specialized for training neural networks. So if you know Python, then you can go. It will take you maybe a week to train the models that I have trained.
Anybody else for any questions, please?
There are different very good courses. If you guys are interested, you can look at Coursera and all these things where you will find really interesting courses. Certification for NLP. Yeah, certification course. There are a lot of certification courses in Coursera or Udemy. You guys can go there, or you can look at YouTube. There will be lots of videos there. You can just get started there. All you need is like Python as a language. If you know Python, then you can go into kind of different online, courses like Coursera, Udacity, Udemy, all these courses websites. Even I think where Indian government has this government, the Ministry of Health and Resource Department has this NPTEL, right? So you can find a lot of they are free of cost in NPTEL. So I think so. NPTEL has actually launched a free kind of course on this. You should look at NPTEL. So go to NPTEL. I forgot the name of the website where there is a free course that is going on. Please enroll there. Government of India is giving this free of cost to all the students. Okay. So computer vision are developed using neural networks, but I don't think Java is a language which has the capability to do it. There might be some libraries, but they are not very well maintained. Python is a go-to library. Are these software on computer vision market are developed? Yeah, it is developed using neural networks. Yeah. Any other question? So yeah, I think if there are no other questions, I think yeah, sure. I mean, you can using Python, you can actually go into the image processing. Yeah, right. Right, Tansin. Yeah.
Girls, any more? Is that all?
Yeah, NLP you can use the same thing for computer vision as well.
Alekia, she's typing her question still, sir.
What do you mean by high efficiency? Sorry. Overtrained model. So there are different kinds of tools to so it is called accuracy, or it is called overfitting. Efficiency is not the right term. Yeah, we have to regularization and different kinds of other techniques to tackle it, which actually solves the overtrained problem. Yeah, I mean, you can look at Andrew Ng's course. That course actually is free of cost in Coursera, and that explains all these things very well. Yeah, no problem.
Anybody more? Anybody with any questions further? So I think that's about it, sir.
Okay. Thank you guys.
Thank you so much, sir, that on a short note you've taken up this session. Thanks a lot.
Thanks, yeah. Thanks, Anisha, for for all the efforts, because like you reached out and also all the invitation and everything you take good care. So yeah,
Sure.
thanks for that.
Thank you so much, sir. So if you don't mind, if it would be great if you can share us this PPT, because if in case any
I will
student,
send you this.
yeah, please. So I'll get in touch with you again, sir,
Sure.
for any other further, if at all we are planning anything further, I'll get in touch with you.
No problem, yeah.
I hope that we'll have this cordial relationship further as well.
Sure, no problem.
Thank you, sir. Thank you, sir. Thanks a lot.
Yeah, thanks.
Thank you. Girls, we have our next session at 2 o'clock. It's by Madhu Vadlamudi, who is the manager at Novartis. So he's going to talk about what are the myths of AI. So I request you to be 5 or 10 minutes before 2. All right. And we'll be taking the next session attendance at 2:10 sharp. All right.